My name is Richard Furrow, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family. I'm cloud hired.
I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired. Because of Google Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the GlowCloud team.
Welcome, everyone. We are here for the completely free Google Professional Cloud Architect Certification Training Program. We have 2 weeks of fun. I am joined here by Leopoldo Paredes. He's part of our team. He's got a master's degree, about 20 years experience in tech. And Leo made some fun labs for you along the way, so I'm happy he's going to be here. He's going to assist me along the way. I will cover the Google Professional Cloud Architect training, more of the certification materials, how the technology works, why it works, how the pieces and parts fit in, which is fun. And this time we decided for the engineers out there to actually do demos, and Leo's going to join me here. So thank you so much for that, Leo. I want to let you know about the format for the next couple of days. We've got a lot of fun. We've got a fun-filled, educational-packed 2 weeks. Today, we're going to go for about 4 hours. We're going to go between 3 and 4 hours every single day for the next 2 weeks, but we're going to kick it off today with a nice 4-hour start. There's a tentative description in the of a tentative schedule in the description. Today, we're going to cover some things related to the Google Cloud at a high level. Tomorrow, we'll cover IAM. We'll have a couple of days of networking and then some compute this week. And then next week, we have lots and lots of fun. So welcome, everyone. We're going to have a lot of fun. Before we begin, I want to tell you about a couple of free things that we have going on for you right now. The first thing that I want to tell you is that there is a study guide that goes along with this course. My team, literally speaking, went through the training materials that I created, and they created a study guide for you. It's a good 550 plus page study guide that's going to really help you easily pass the Google Professional Cloud Architect Certification exam along with our training. So I want to make sure you get it. It's completely free. Follow along with our training, and it's free. I also want to tell you that on Thursday, maybe you want to know how to become an actual cloud architect and work as a cloud architect. So on Thursday, we'll have a webinar where we cover what does a cloud architect do. We'll cover the cloud architect job. We'll cover the skills that you need and what it's going to take to be hired, which is different than it's going to take to be certified. So we have that, and it's going to be completely free. And of course, check out this schedule. It'll be in the description each day. We'll tune and modify as things going on, but we're going to have a lot of fun. Leo, do you want to say anything before we begin?
Well, thank you for the introduction, Mike. And it's a pleasure to be here, and it will be a lot of fun. Thank you.
It will be a lot of fun. So Leo's a great architect, but he also got pretty geeky on the tech because of his 2+ decades of engineering background. So we'll have some fun for you for the hands-on tech professionals, and obviously I'll do the architecture side. So we'll begin. Can you just do me a favor? It takes a lot of time, effort, and money to put one of these courses together. And I mean as much as a Mercedes would cost as a general rule. So if you can invite others for free, maybe make a quick post or a quick LinkedIn post or Twitter post or Facebook thing and just invite a friend. or send a text message to a friend and invite them, because we want to help as many people all over the world as we can. So if you like the content, please leave a like, or subscribe. It'll signal the algorithm to share to more people. Please share with your friends. And so I know that you're awake, alert, and oriented and ready to go. Give me a hashtag Google Professional Cloud Architect. When I see a bunch of them pouring in, I know that you are ready to start the course, and we will start. I'm going to let you know that I did pre-record some of this content, or a lot of the content, but I'm still going to be here to answer live questions. I did it because I was having some back issues and I knew I had to get spinal surgery, which I did. So I wanted to make sure, surgery, no surgery, we had a really good, fun-filled 2 weeks of training. So that's why I did it. So Chris, let's start the content. Let's see those hashtags in that chat box, and let's begin with our Google Professional Cloud Architect Certification Bootcamp to prepare you for the Google Professional Cloud Architect Certification exam.
In this video, we're going to begin
and also
our
let me know
discussion
where you're at in the chat.
on cloud computing and the Google Cloud. And in order to start this, I really want to talk about what is cloud computing. And there's a lot of definitions out there on cloud computing, and they're really hard to understand. So what I want to do is I want to take you through a journey. We're going to go look at what an organization's data center used to be like prior to moving to the cloud, and most organizations still have one of these data centers. Then we're going to look at what it takes to actually design a cloud provider of systems, and I've designed many clouds for the last few decades. And then we'll really break it down into what is it you're actually getting with regards to cloud computing. So the first thing that I want to do is walk you through an organization's data center. Here's what a high availability data center would look like. And if you understand the data center, you'll understand cloud computing. So in a data center, it is really a building. And the building is going to be where we house all of our technology resources for an organization. So what's involved in a normal data center? Well, we need a couple of things in these buildings. We're going to need to have power in the buildings. Now, whenever possible, we use two different power companies, because if a power company has a failure, we would like a backup power company. So we typically use multiple power companies, and we typically use multiple transformers coming in the building to take the high voltage to the normal voltage used by our systems. We're also going to have networking connections that go out to the internet, which will be protected by firewalls and things. And these will typically connect us to multiple internet service providers. We can't have a single internet service provider. It's a single point of failure. So we'll have net routers and switches and networking connections going out to the internet. Now we will have other routers that are going to go to other locations that we own. Maybe we have a New York office, a San Francisco office. Maybe we have a private line or a link between them. So we're going to have our networking connections that go to our other sites. Now, if we have a power failure in a data center, we're going to have a problem. So we're typically going to have generators, more than one, sitting in our facility that can power our systems if and when the two power companies were to go out at the same time. And we typically have something called an uninterruptible power supply and a power conditioning system, which is going to smooth out and condition the power to make it good and clean. And then after that, provide battery backup. So power goes out, it takes 60 seconds for the generators to kick in, and the battery keeps it powered up. Servers don't reboot, don't crash, everything is up and running. Now, in our data centers, we're going to have the network, which is where our devices plug into. And in the network, for example, we'll have a whole lot of routers and switches, and they'll typically be running a routing protocol. And what will we plug into the network other than routers and switches? Servers. And the servers are going to be where all the compute is done, no matter what type of model we run. Whether we're doing serverless or platform as a service, they're all going to be running on servers. And we typically have storage area networks. Block storage, for example, will typically have file servers. We'll typically also have object storage environments in a data center. And basically, these are going to be systems that are packed full of hard drives in a RAID configuration and provide storage for our servers. Now, this is a traditional data center. Right now, it's a hardware-based data center. What have we done for the last few years in our data centers? Well, we put a control plane in this, and what the control plane does is as follows. The control plane, and this could be a VMware control plane. In today's world, it could be cloud software like Nutanix or OpenStack. Here's what the control plane does. The control plane will manage the resources in the entire system. So if I tell the control plane that I need 5 virtual machines, The control plane will look and see which servers have available capacity, and it will put those virtual machines. I tell the control plane to delete the virtual machines, they'll come off of these virtual machines. I might also have a control plane for my containerized environment, which might mean I've got some Kubernetes servers running here. Let's say a K8. We've got our control plane over there. And then, of course, what's going to happen? We're going to have our nodes that actually do the work. So we like the worker nodes. And where are those worker nodes going to be? And where's all this stuff going to run? All this stuff will still be running inside of the organization servers. If we wanted to create a Lambda function in an organization's control plane, we've got function as a service as a general rule. We'd upload our code and it would be running on all these servers. So what are you noticing? This is the basic compute of the data center. Now, data centers look like I've described since 1999 when VMware invented the hypervisor. Okay, so now what is the Google Cloud? What is any cloud? Well, let's look at it. Now we have a public cloud provider. And what changed? Well, we have more routers and switches than before, because now we might need to have the equipment that for 1,000 customers. Now we need more servers because we have it, and we need more storage boxes and more storage area networks. What do we still need as a provider? We need the HVAC system to cool it off, the air conditioning. We need the generators to back up the power. We need the uninterruptible power supplies to back up the power. We deal with multiple power companies. In some cases, the cloud providers have so much power utilization, they're using their own nuclear power plants, or they're looking into building them. We have a lot of networking connections that go out to the internet. As a cloud provider, we're probably connected to every major internet service provider in the world to provide optimal routing. Then we have connections going back to our other regions and other availability zones. That's our intranet connections. And of course, we've got power. Now, the difference is now the control plane is going to be a little different. So instead of the control plane being something that we own or rent or pay for, like Nutanix or OpenStack or Nutanix or OpenStack or VMware, now all of a sudden this is managed by the cloud provider. So now the Google Cloud has their own control plane. And when you run something like a Google function, the Google function gets scheduled from the control plane and it rolls on a bunch of servers. When you want to deal with a containerized environment, just like in our data center, we'll have the Kubernetes servers running, and the pods where the work is done is going to be done on a virtual machine going back to the server. Application virtualization, upload our code and it runs, again gets done on the server. So, is there any difference between the data centers we built for the last 30 years and the cloud provider's data center? No. The only thing different is the scale. So when we go to a data center, a cloud provider, what we're doing is we're outsourcing our data center services. Instead of building it ourselves, we're using pre-made services from another cloud provider. And ultimately what happens when we're in cloud computing is we end up getting a virtual private data center. And what's this going to look like? And I hope this makes what is cloud computing easy to understand, and then the rest of what we talk about makes more sense. So in this particular environment, what is it we're really dealing with in the cloud? Well, what we do in the cloud is we buy a virtual private data center, and it's typically called something called a VPC. And your VPC, realistically speaking, is going to be your virtual private cloud. Azure calls it a VNet. So whatever the cloud providers call it, but your VPC, VNet, is basically your virtual private data center. And what are you going to put in here? Well, you're going to keep your servers in here, same servers like you used to have. Now, servers, so you'll have a bunch of them. Now you're going to have a virtual router and all the routing, because nothing works without the networking. So you're going to have virtual networking instead of the cables. And the cables will be software based. We'll have our servers. We're going to have storage, which we're going to connect to, some kind of storage, which we're going to connect to. We're going to be running our applications. It's typically on virtual machines or containers or something like that. When we need to load share, we'll be using load balancers, but they'll be virtual load balancers. and we'll put our applications in our databases. So what are we putting in here? Our servers, our storage, our compute, our security, our everything. We're renting a data center when we go to the cloud provider. So we build it ourselves and own it with a private data center. With a public cloud provider, we're renting the space. Cloud computing is a landlord-tenant business. The cloud provider has to build the same thing you would, and then they rent it out to you. It's the equivalent of a hotel room versus a home. The data center is a home. You build it, you own it, you can control everything. And the cloud provider is like renting a room in a hotel. There's going to be 1,000 rooms in this hotel potentially. And each room is somewhat isolated from each other. At least it's logically isolated from each other. And it's your own private space. So now you know what is cloud computing. Now, when we talk about Google Cloud versus other clouds, they're going to be very similar. Because all cloud providers are doing is they're renting out of their data centers. Now, the good news is 98% of organizations are multi-cloud, and that's going to put them in a position where they're sharing the load across multiple clouds, which gives businesses the ability to pick the cloud provider that does certain things best, not have any single points of failure, and negotiate pricing with each other. For example, maybe the Google Cloud does something better on big data, and maybe the Nutanix Cloud is cheapest for high-performance compute, and maybe AWS has something big in one area that we want to use. Combine all three and we get maximum benefits. So that's what we're going to talk about. So what is compute? Well, compute generally means processing power. It's the term that's going to do the actual work. So it could be a virtual machine and it's CPU power, DRAM power, and networking and storage. Or we could be using, in an AI environment, we might be doing our compute across graphics processors. And those graphic processors will also have a lot of memory and storage and things that are going to be necessary as part of what they do on their systems to integrate into the system. So compute is the work, the load. So no matter what, the compute is always done on a server. Yeah, our servers do the compute in cloud computing and data center work. Now, even when we talk about serverless, it's still being done on a server, but we'll talk more about that, about how that's hidden from you. So all work, all compute is going to be done on a server, and the server's processor determines what it can do. The type of processor, the speed of each core, the number of cores, the amount of DRAM, the networking speed that the system can handle, all of that is going to be compute. And compute is going to be the backbone of everything. It's going to be doing the analyzing the data, running the applications, performing the task. And in a data center, if we've got a private control plane, like that OpenStack or Nutanix we're talking about, we can create our virtual machines in any size we want. In the cloud provider, they're going to have pre-made virtual machines of various configurations that we can choose, for the most part, of CPU, DRAM type environments. And we're just going to pick the right kind of machine, for example, that would match the kind of machine that we would need in a data center, because all cloud computing is a virtual data center. So if we're going to size our virtual machines, we're going, in the cloud, we're going to do it exactly the way we did in the data center. If I've got a workload that needs to be on a virtual machine, and we can talk about what that is throughout the program, but if I've got a workload that should run on a virtual machine, and if it's running on 8 cores right now and 64 gigs of DRAM, then when we move it to the cloud, if it's an optimal performance, maybe we move it exactly the same. Or maybe when we move to the cloud, we don't need as much capacity. We can use less capacity and then add capacity as needed. But we're going to have to size our virtual machines based upon the capacity utilization and the correct strategy for us. In many cases, it's going to be cheaper to run off a few small servers than it might be one giant server. In other cases, it'll be cheaper to run 2 giant servers than 10 small servers. And you're going to have to analyze that, and that's how we're going to be making these determinations as well. Now, Google Cloud calls virtual machines compute engine. And a lot of these certifications are going to be vocabulary of what does Google call it. Google calls their virtual machines compute engine. Azure calls it an Azure virtual machine. Oracle calls it a virtual machine. AWS calls it Elastic Compute Cloud. So understand that your virtual machine is a virtual machine, but in Google it's called compute engine instance. And there will be predefined instances that you can select for it, which one is going to be right for you. Now, in the data center, we can create an image or a bit-by-bit copy of our virtual machines. And we can take that image and launch that virtual machine as another server at any one time. Guess what? In the cloud environment, Google and all cloud providers give us the ability to create an image or use a configured image. And we can take a virtual machine image from the data center, convert it to a Google machine, the Google virtual machine image, and run it directly in the Google Cloud. We can often go the exact opposite direction. Or with the Google Cloud, we can use a template to create a full configuration of a virtual machine, such as the operating system, the type of disk, any metadata that we need to do. And by doing so, we can make sure that our operating system and our images are consistent. It's going to be fast to deploy them. We can make sure that the security configurations of an operating system, the kinds of things that need to be locked down, for example, standard patch level can be done again and again and again in a repeatable manner. And imaging enables us to produce something once and then allow many other people to use it in the future. And of course, if we need an image, we could either convert one that we have from our data center, we can use one of these Google tools, or all the cloud providers have a marketplace that's going to give us pre-built images of specific applications. Maybe we want 2 next-generation firewalls from, say, Cisco, and we can get them from a marketplace. Or maybe we want a various database server or a type of web server that we don't want to manually set up, and we can pay for a pre-made commercial solution. And we can use that commercial solution pretty much in all single clouds. Now, of course, we've got a lot of operating systems we can use. We can use things like Ubuntu or Debian or CentOS or even Windows servers. And we can create any kind of operating systems if we want, and we can have them tailored to our workloads, upload them, and then they can be used again, again, and again. And of course, those pre-configured images really make life a lot easier. Now, when a virtual machine comes up, we can automate it, and it's called bootstrapping. So we can use a very simple script as we launch the virtual machine to do it. So we could create a startup script. The system comes up. The system updates the operating system. Then the system may actually install the applications that are needed. Then it patches all the applications. And that happens in an automated manner when the system's coming up. We could come up with a little script for that. It's called bootstrapping, widely used in cloud computing, and really can help automating. You may hear things of a bootstrap script in AWS, same thing we're talking about here. Okay, now let's talk about how we buy our virtual machines in the cloud. Now, we're going to be often calling virtual machines instances, and each instance is an additional virtual machine. But the term compute engine instance is Google's marketing term for a virtual machine. And there's going to be several ways we can choose what our type of instance is that we actually use. For example, we can use an on-demand instance, which basically is we access it when we want it. If we add capacity, we add it on demand. When we no longer need it, we shrink it down. So this is ultimate flexibility. And we pay for the resources that we use the time we're actually using them. So if I've got an unpredictable workload, and I have no idea that might need 1 server now and then 100 servers tomorrow and then 3 servers the next day, this is where we use our on-demand instances. And we do this because we know we have no idea what they're going to be. And a sales website could be an example of this. For example, we might need 10 servers normally for most of the time, and then periodically we need 100 during a big sale. So we could typically do this. We could typically commit to, which is what I'm going to talk to next, 10 servers, and then add on-demand additional capacity when we need it. So what is committed use? And all the cloud providers have this. Committed use is the cloud provider will give you a cheaper price if you agree to the following. Pay for it for, say, 3 years or an extended period of time. And by guaranteeing the cloud provider a certain amount of money you're going to spend, it makes budgeting and planning much easier on the cloud provider because they know where the revenue is coming from. Makes it easier for them to invest in new technology. So that puts them in a much better position. So you get a discount, potentially a relatively good discount, if you commit to spending a lot of money for a long period of time. Now, the next thing that we can talk about is something called a preemptible type instance. It's the equivalent of an AWS Spot instance. And the cloud providers have these big, giant data centers. These servers are up, they're running, and all kinds of stuff is going on at all times, right? So they have excess capacity. Now, all the cloud providers give the ability to bid on excess capacity in an auction-like manner and for excess capacity. And by doing so, you get some very cheap prices. But it comes at a price. So let's say we needed 500 servers for 30 hours. In a perfect world, if our workload is stateless and can be started and stopped at any time, what we can do is we can bid a low price for the number of servers that we need, and it can run. The workload can run on these preemptible virtual machines, and we will get up to 80% off. Here's the problem. Let's say we agree to pay $1 an hour for this virtual machine, for example, and somebody outbids us and pays $1.01. The Google Cloud provider can shut off or preempt our systems because we're no longer paying the most amount of money and go to somebody else. There's typically with the cloud provider an opportunity when this is happening. There's like 5 minutes notice. Your systems will be shut off in 5 minutes unless you want to pay more, which may not even be anybody be able to fix it in the meantime, but that's a preemptible machine. So to recover it on demand, when you don't know what your capacity is, you use this. Agility, which is a beautiful thing, but you're going to pay for the agility. Committed use, you're guaranteeing the cloud provider a certain amount of money you're going to spend, and they give you a discount. And for workloads that you need cost sensitivity or things that can actually happen as batch jobs for workloads that can allow starts and stops, the preemptible instances can really help you save some costs. And optimal cost management is going to be using the right ones for the right places. Now, let's talk about IP addressing. So any system that's on a network, if it's going to have to talk to somebody else, is going to have a unique IP address. And when we deal with virtual machines, we'll have the opportunities to use private addresses and public addresses. Now, inside of your data center, inside of your organization, you're always going to use private addresses if you're using IPv4. And we don't have enough public IP addresses. So typically, you'll see organizations, they use private IP addressing internally. And you may often hear of the IP private addressing space. And IP addresses were actually spelled out by the Internet Engineering Task Force in RFC 1925. And I'll show you what the range actually is. So we have the 10.0.0.0/8 address space, and this is typically used private internally. We also have the 172.16.0.0 all the way to 172.31.0.0. And this is going to be, they're all going to be these /16s. And we have the 192.168.0.0/16. 16. These are addresses that we use internally. Now, if we need to connect a system to the outside world, for example, a web server, the web server needs to either have a public IP address, or if it's behind a load balancer, the load balancer can have the public IP address and load balance between the servers that are behind it, often in a private subnet in cloud computing. But that we can do. Private subnets are inside and not reachable from the internet. Public subnets are to be used for things that you want reachable to the internet. And of course, all the routing and everything else needs to be taken place. Internal IPs used internally, private. External IPs to communicate with the outside world over the public internet, not a private system.
All right. Well, welcome back, everyone. We are here. Want to see if any questions have come up along the way, anything that we need to clarify, make sure everybody's learning something and having a good time. So we're back here for that. So we'll see if there's any questions from my team. As a reminder, if you just joined us, we have a completely free study guide that's going to go along with this. What you need to do is sign up. The link is in the description, but it's also have Chris from my team drop it in the chat box. All you need to do is sign up for it. Now, it may take 10 to 15 minutes to get it. Because we get such a large number of requests, we can't have our email server send like thousands of emails at the same time. We have to stagger them over a few minutes. So please do get your copy of that completely free study guide. We want you to have a great time with this completely free Google Professional Cloud Architect Certification Bootcamp. Are there any questions that are here? And while I wait for your questions, I'd like to ask everyone, if you're having a good time and learning something, please give the video a like, subscribe to our channel, and hit the bell to be notified of new videos for your architecture career. And I also want to verbally clarify, when I referred to the private IP address space of the 10.0.0.8, the 192.16.0.0/12, as well as the 192.168.0.0/16. That's actually RFC 1918. And I put it in the chat box as I did that. I must have been thinking of RFC 1925 for another reason as I was describing that, but it is definitely RFC 1918 that specifies private address space. Chris, did you see any questions come in? Is everybody awake? Because there's no questions. Hopefully everybody enjoyed the what is cloud computing and how does cloud computing work. So Team Escalate has a question on what is bootstrapping. So what a great question. So Team Escalate, let's say we have a base Linux image that we have as a virtual machine in the cloud. It's either a standard Red Hat Linux image or a standard Windows image or a standard everything. Now, when that image comes up, it's not really ready for business use. Maybe that image needs to update the operating system. Maybe it needs to actually install some software. Now, I'm not Mr. Linux. I haven't touched the Linux system in a long time because it's not really something architects do. But I do remember building some stuff for fun in my house that did use Linux. So let's say I had an Ubuntu Linux system and we were using it in any cloud provider. As soon as that boots, we could have it do like a sudo apt-get update, where it would update the packages. And then after we did that, we could do like a sudo apt install HTTPD or Apache or whatever the web server could kind of be. And then we could do a minimal configuration. Very similar to a bash shell script on server boot up and the data center that we could do. And that's really what it is. So it's basically taking a virtual machine and pre-configuring it for use in your VPC. Hope that helps. If you want me to explain deeper in a different way, let me know and I'm happy to do so. So, great question, Matthew. The difference between an ephemeral IP and a static IP. And we'll cover this much more later. But, here's the thing. Something that's ephemeral changes. It can change over time. Now, if I had a user and they were sitting behind a firewall and with a private IP address and I needed to temporarily use any kind of IP address I wanted to for them to connect to the outside world, that's fine. Because if it changes tomorrow, it doesn't matter. But what if I have a server that needs to be reached all the time at the same IP address? Well, that's where we're going to use a static IP address. And, we could use that in our data center. It could be a private server on the internet, or it could be a public server on the internet. But the point is we've got a static IP address. And, we could have 5 websites with internal 5 web servers with static IP addresses internally, which would be sitting behind a load balancer that would be natting them to a single public address and load sharing across them externally. We could do that. But the point is something that's ephemeral is always dynamic. It may be there, it may not be there. Anything that's static manually needs to be there. And anything really important, for the most part, needs to be static. Good question. Any others? Okay, if not, make sure you've got a copy of that, what was I going to say? A copy of the study guide. Make sure that once every Thursday we do a how to become an actual cloud architect, which is different than being certified. All the skills you'll need, what we do, how to apply, how to not get rejected by HR, and we cover all those things completely free. And our how to become an architect webinar, I'll have my team drop a link to that in the chat box, but also in the description of this video. And give me a hashtag Google Professional Cloud Architect, so I know that you're preparing for this certification. And Chris, let's get back to the content.
Let's talk about cloud computing. Let's talk about digital transformation. So prior to the internet, people worked a certain way. After the internet, people were able to do things that were never possible. Mail no longer took a week for me to send mail from myself in, say, Pennsylvania, Philadelphia to my relatives in Greece. It was instant over an email message. What used to be a $4 a minute phone call from Philadelphia to call my family in Nepetamos, Greece, all of the $4 per minute all of a sudden was free. over an IP phone or an IP voice over IP link. So the internet changed a lot. The internet gave people access to information, they gave access to other people, and it gave access to a wide variety of things, and it changed things. Now, it changed a lot of things, the way people lived, worked, and played for the most part. Now, cloud computing is there to help as well. Now, we have to understand that cloud computing is not new. All cloud computing is renting space in someone else's place versus doing it yourself. So what does this really mean? It means that cloud computing does provide some advantages and also some things that are not as good as the traditional data center. And what is cloud architecture? Architecture is about looking at all your available options, evaluating all trade-offs, and then choosing the right one based upon your organization. But cloud computing does something that's pretty great. First, cloud computing is already there. So, in a normal world, I want to roll out a new application. I have to call Cisco. I buy my routers and switches. I call Dell, for example. I mean, it could be IBM, whoever. I buy our servers. I buy our storage. I call Palo Alto and Cisco to buy firewalls, for example, and other appliances. I'm dealing with other companies. And I have to build it, and then I have to have the capacity on my systems to be able to run my business. With cloud computing, I don't technically need to build it. I can literally rent it immediately. And in the traditional data center, it makes some time, 4 weeks to get servers delivered, another couple of weeks to get the servers racked, stacked, hypervisors, what have you, put on the systems and applications installed. And in the cloud, we can have someone write a Terraform script or an infrastructure as code script and do this in a matter of minutes or seconds versus days, weeks, or months in the data center. So the bottleneck, the performance bottlenecks of having to build it yourself are often mitigated in cloud computing. So cloud computing promotes a lot of business agility. And this agility enables businesses, potentially speaking, to innovate faster. So instead of the organization focusing on an infrastructure, they can focus on their business more, and they're going to pay the price. Now, understand, for the purpose of the exam, cloud computing is going to be cheaper. For the purposes of reality, cloud computing may cost 200 to 300% more. Those are David Lithicum's numbers. He was Deloitte's chief cloud strategist. When he left, those were his numbers and his experience. David Lithicum is an expert in the field. I also see 2 to 3 times or more to run things in the cloud compared to the data center. But it's the agility, and the agility to launch something fast is a huge business value. Now, we have to understand that Google is very big. They're very strong, they're very knowledgeable, and all the cloud providers like Google and Microsoft and Amazon and others, they are experts at designing data centers and running and operating these data centers. So understand completely that they will do it right. And for an organization that doesn't have a lot of expertise in developing their data center, outsourcing to a company like Google and the Google Cloud might be a great way to do it. So there's a lot that we get out of cloud computing. We get this agility, what have you. And these are things we typically want to talk about. I know cloud computing can shape the future of work, for example. It will make it easier for people to work in various parts of the world because cloud computing is ubiquitous. It's absolutely everywhere. So cloud computing is here to stay, and we'll be using it. And it's renting data centers versus building our own. Now, one of the things to think about is this on-demand ability. The fact that the systems are there and all you need to do is launch a script or have one of your DevOps engineers or cloud engineers launch a script and you're up and running. It's incredible. I can tell you, for example, I had a friend and he had to test various routers for capabilities. He had someone from his team launch an infrastructure as code script, spun up 10,000 virtual machines, used those virtual machines to really torture test the network. And the networking gear did great. And they found out the network, it was a great way to test it. On-demand availability, use the systems as much as fast as you can, and then shut it down when you're done. That was hugely advanced. So just having it there. Now, we also tend to have the ability in the cloud providers, they have a lot of services that are already pre-made. Use this thing pre-made and managed, use this thing pre-managed. So it enables us to build easier service-based architectures, which is completely true. If we use the cloud provider's enable tooling, and they've got a library for a few things, and we'll talk about those libraries throughout this program, because that's a lot of what the certification is about, you'll understand how you can do things faster and maybe be more service-oriented. What you'll also learn throughout this program is if when you use these cloud providers' native tools and proprietary tools, it's going to make it a whole lot harder for you to accommodate today's modern multi-cloud architectures. And we'll talk about them when we get through them. So let's talk about our 3 cloud options. And I really want to show you the options and why. So if we go to this chart, and I had to make this chart for your exam. So keep that in mind. So if we deal with the public cloud, we don't have ultimate control of the security. And because of that, we're also in a shared network. So in the data center, we have to worry about ourselves getting hacked. In the cloud, we have to worry about the cloud provider getting hacked and our stuff being hacked, which is an additional attack vector. So cloud computing is less secure. Typically speaking, we have a lot less control. We can't do anywhere near the segmentation network security in the public cloud that we can do in the private cloud. Now, the public cloud is extremely scalable at any level of capacity when you need. This is awesome. It's terrific, and we love that. The public cloud is accessible. It's just there. Just turn it on. Now, here's the interesting thing to think about. In the cloud, there may be 1 million other customers that you're sharing the same cloud with. You might be on a virtual machine, call it a compute engine instance, and on the server that's holding your virtual machine, there may be 50 other businesses of virtual machines there, including potentially your competitors. So, shared services, theoretically, you can't do a hypervisor escape and go from one system to another, but yet when it really matters, organizations use private servers. Now, the ownership of the gear is going to be the cloud provider, where if you're dealing with the cloud. Now, the cloud computing they try to say is cost effective. If you actually look at what we're seeing in the market, the people are leaving the cloud because it costs so much more than they ever planned. They found out that the cost effectiveness, no matter how they designed it, lift and shift it, modified it, it was never cheaper on the cloud. And it can't be, because the cloud provider has to build the same systems you do, and then they have to manage these systems, sell them, and deal with all the things that go along with running them. So it's a landlord-tenant business, and if it costs a landlord $1,000 a month more operating costs on a property, they can't sell it for $1,000. They can't sell it for less. They have to sell it for more, maybe $1,500. Public cloud, AWS, GCP, Azure. Now let's talk about the cloud. The private cloud is the most secure. I can do things on my network where 2 servers can't speak to each other, even on the subnets, without even using an ACL. I can rate limit bad traffic. I can prioritize business traffic over worm traffic. I can't do any of this on the private cloud on the public cloud because it's a shared network, but I can do it all on my public cloud. Now, in my private cloud, I've got relatively limited scalability. And why is that? I only have whatever capacity I have left. How about accessing this? You've got to have access to this data center, which in many cases makes it more secure. You're not accessing over the internet. You might have to access it over a VPN. So this might even be better. Now, our servers in the private cloud are shared servers. Are private. We own them. Only our own company stuff is on these servers. And we can even specify which servers need more security than others and host higher security workloads on various sets of servers. Who owns the private cloud? We do. We can do anything we want. Now, the reality is for high volume workloads, the private cloud is far, far, far cheaper. For an example, you could buy a server from Dell for about $300,000. And if you run that server at max capacity for about 4 years in a cloud provider, you can be dealing with several $1 million. So, but you have less overhead. So we have to think about the private cloud. It often ends up being cheaper for high volume workload, and it's often too expensive for sporadic workloads. And I can tell you why. Sporadic workloads are cheaper on the cloud. Let's say we built the website for a global retailer. The global retailer had 1 million hits per minute during Christmas time and 100,000 hits every day. In the data center, we have to build for that 1 million hits because we have to have the capacity for the Christmas, or we need that capacity to be able to handle it at some point. In the in the public cloud, we can build it for 100,000 and then use auto scaling to handle the capacity that we need at a cell. in the private cloud, we have to have that capacity ahead of time. So that's why sporadic workloads are often cheaper in the cloud, because you can underbuild it and then use auto scaling, which we'll talk about throughout this program. But workloads that run all the time are often much cheaper, 5-10 times cheaper, and potentially even in the data center. So the private cloud. We're dealing with here companies like Dell, VMware, Nutanix, IBM, OpenStack, that kind of thing. And what's this hybrid cloud? Now, this is a really unique thing, and most organizations are using this. In fact, most organizations have what you call a hybrid multi-cloud, where they use like 1 or 2 public clouds in addition to the private cloud. Now, the private cloud's got a lot of security. Why? We can put the most critical workloads where they need the most security, where we can provide it, which is the private clouds, and we can put other stuff in the data center, in the public cloud. Now, the hybrid cloud's highly scalable. Why? Because we build for what we need in our data center, and we can just add capacity on demand to the cloud. So, for example, if we have 10 servers running here and we need extra capacity, just add the capacity in the cloud on demand, and that can be done dynamically with our private cloud software like Nutanix and OpenStack. It's called cloud bursting. Accessibility. Now, my cloud stuff is pretty easy to get to. My data center stuff is a little hard, so now it comes in the medium. Now on my servers, I can put my own private servers. I can use shared servers, so it's now mixed. Who owns it? Well, the hybrid cloud, we own our stuff, but we're still renting stuff that's owned by the service provider. Cost is typically the cheapest in reality with the hybrid cloud, because we can put those scaling workloads in the public cloud, which are often cheapest, but those high performance, constantly running workloads in our data center. But for the purposes of the exam, we'll call it moderate expensive. And there's lots of providers of hybrid clouds. Get a Nutanix cloud connected to AWS, it's a hybrid cloud. Get an OpenStack cloud connected to Google, it's a hybrid cloud. Have a VMware cloud and connected to Azure, it is a hybrid cloud. So that's really what we're actually talking about. So we're going to ultimately use all three in the majority of enterprises. Like I said, 98% of enterprises are multi-cloud at this point, and there's lots of reasons for it. The agility, the availability, the best tooling of each provider, for example, all the same thing. So let's talk about responsibility models and how they're actually different. In the private data center, you own everything because it's yours. You also have ultimate control of what you use. You control 100% of what you're using. Now, let's talk about what actually happens in the cloud computing environment. You do not have any control over the cloud provider's underlying infrastructure. You have no control over the routers, no control over their switches. You have no control over how they secure their infrastructure, for example. So in cloud computing, you've got this shared responsibility model, which basically means you're responsible for your stuff. All the stuff that sits in your VPC or your VNet, your private data center. And the cloud provider is responsible for their stuff. All the infrastructure that makes it that you can do what you need to get your things done. And we're always going to have to consider that, especially when we get to security, and we'll talk more about it. Now, one thing that's definitely true is when we take our stuff from a buying model to a renting model, we change from a capital expenditure to an operational expenditure. This could be the best thing or the worst thing that would ever happen to a business. And that's going to be based upon the organization's capital structure, which is why cloud architects and enterprise architects and architects that we train we are taught to evaluate the organization's capital structure and cost of capital to build the business case on what's going to be most operationally efficient and cost effective for that organization. And you'd be surprised, often it's not going to be the public cloud. Sometimes it's all public cloud. It's usually some form of a hybrid cloud or a hybrid multi-cloud. Now, another way we can manage our costs in cloud computing and understand it is where we put our stuff. So you may hear cloud costs have got out of control. You hear escalating cloud costs. People are leaving the cloud. Well, they're still going to the cloud as they're leaving the cloud at just as fast of a pace. So what is going on? If we put the right resources in the right place. For example, that server that costs $300,000 and might cost us $5 million in the cloud, stick that server in the data center. Now take your other stuff and move it to the cloud. So we need to understand that. Now, we need to understand while services in the cloud are typically much more expensive, we also need a less significant staff because we no longer have to manage the network, the data center, and all this stuff. We're managing virtual assets. And that might reduce some of the IT overhead, which enables a business to put its people on more core business activities. Acceleration of innovation with cloud computing. Yeah, the stuff's there. There's so many pre-made tools. You can get stuff up and running very quickly. Cloud's the easy button. So we have to consider that. The business considerations, the impact of the simplicity of the cloud. And even if the cloud is twice as expensive, that simplicity and elegance and time to market might still be worth it, depending upon how we would look at that architectural design, what that business is trying to achieve. Now, I'll tell you this, to a degree, businesses that weren't cloud-based were starting to look like old-time businesses. A couple of years ago, they had lower valuations and stock valuations, but now companies are getting a little wiser. And we've seen companies even like LinkedIn, which were owned by Microsoft, that was supposed to go to the Microsoft cloud that kept it in their data center. So we're getting to a point where the industry perception of not being on the cloud doesn't feel so legacy or old school anymore. But at the same time, we're actually still cloud-based is a lot of what we're doing. I'll also tell you from a perspective of the employees, a lot of your employees feel good about working on cool stuff, and you can often attract better talent. And many times cloud computing, you can attract people that are more excited about it. So keep that in the back of your mind. So let's talk about the actual cloud architectures and what they actually are, because we have some hybrid cloud, private cloud, hybrid multi-cloud, and I want you to truly understand what they are. I'll probably even discuss a community cloud, although I don't think you'll see that on the exam. So here's your typical hybrid cloud. Your hybrid cloud is we've got our own data center. Let's say we're running, last time I used Nutanix, so in this case, we're talking OpenStack, cloud software from IBM Red Hat. And now we connect this to AWS. Got a router on our side, or multiple routers, and we've got a virtual router on the AWS side. We buy a private line connection between them, a direct connection. AWS calls it, Azure calls it an express route, Google calls it, I'm pretty sure, a direct interconnect. Same thing, same private lines we've been using for the last few decades. And we've got a hybrid cloud. Now, how do we turn that into a hybrid multi-cloud? Well, we've got AWS that we're working with. We've got Google Cloud. We get another private line, for example, between AWS and Google, and now we're in a hybrid multi-cloud. Now, this, realistically speaking, is pretty good. Let's say we really like Google's AI capabilities, and we really like AWS's large amount of infrastructure. So we could create what's called best of breed, where we could use AWS for what it does best, Google for what it does best, and the data center for what it does best, which is the highest performance, highest security, lowest latency compute workloads. So that's your hybrid multi-cloud. We could also just do a multi-cloud architecture, which is just two cloud providers. And all we're doing with two cloud providers is just as following. We're load sharing between them. We can have 50% of our workload go to, say, AWS, and the other 50% of our workload go to Azure. And by doing this, it's not going to increase our cost for the most part, because instead of buying 100% of our stuff here, we're splitting it, kind of like you went to two stores to buy your groceries, no difference. And now we can send half of the traffic to AWS and half of the traffic to Google. All of a sudden, AWS has an outage. All your traffic is sent to Google, and then Google can add capacity with auto scaling to get you 100% within 45 minutes, and you're up and running. So there is that. Obviously, you know what a private cloud is because we designed private clouds. You've seen the public clouds, which is just a single cloud provider. Now, you may also see something called the community cloud, and I want you to know what that is. So let's say we're in Philadelphia, and I'm just using argument's sake. So let's say Philadelphia has 14 hospitals. And maybe those 14 hospitals decide to call themselves the Philly Hospital Cloud. And what we're dealing with in a community cloud is a bunch of organizations get together. They design a cloud. The cloud is designed to be based on exactly what they're looking to actually do. And and it's managed and run by 13 or 14 hospitals. By doing this, they can pool their resources and get an economy of scale and better discounts, but they don't reach hyperscale of the cloud providers where they've got so much overhead, they can still do it cheap, and it can be custom built based upon the needs of a specific community, and that's called a community cloud. Last time we checked, it was not on the Google Professional Cloud Architect exam, but I thought it would be good for you to know. So let's talk about some cloud computing service models. And there's going to be a couple models that we can use. And I want to go through them with you. So the first model we're going to use is infrastructure as a service. And infrastructure as a service is getting an exact virtual data center. And in your virtual data center, you'll have your virtual machines, you'll have your containers, and you'll run it all as if it was the same systems in your data center. Now, when you do this, you have the highest performance. In many cases, you have the absolute most control. But you're also responsible for the most things. And we'll walk through that so you can actually see what those kind of things are actually going to be in a minute. But understand, for the most part, what we're really talking about here is control with that private cloud that we're actually talking about with that infrastructure as a service model. So the next model we could be using is something called platform as a service. And what is platform as a service? And I'm going to give you some visuals in a minute. Platform as a service is, for the most part, when things are pre-made for you and you upload your code and it runs. You put your applications and your data, and all the underlying infrastructure is there. Now, this is the same as application virtualization we've had in the data center for a while. Windows Server does. It had lots of opportunities with VMware, so it's not new. Platform as a service, upload your code and it runs. And the last type of cloud computing model we'll talk about, and then I'm going to really show you what we're talking about with some graphics and things, is what you call software as a service. Software as a service is basically when you access an application via a web browser, it's hosted by somebody else, it's managed by somebody else, and you've got, for the most part, almost no control over the system. Maybe you've got some IAM controls, very simple. It's basically an off-the-shelf application that you're using. So let's look at what we're actually really talking about and what this really means. So if I walk you through this design with infrastructure as a service, let's see what we really have. You're basically renting your virtual data center. So the cloud provider is going to be responsible for the networking, like I said, the shared security of their data centers. They're going to be responsible for their storage, meaning their actual hard drives that are sitting in their storage area networks, their physical servers, and say their hypervisors. You'll be responsible for your virtual networking and your virtual private data center, your operating systems, whatever middleware you're using to connect systems to systems, any applications data, anything necessary to go on. So in infrastructure as a service, you're renting a data center, and all the heavy lifting, the network, the storage, the physical infrastructure, you're going to get in virtual form. And they're responsible for the physical, and you're responsible for your stuff. Now, when we get into platform as a service, look, the only thing you're really dealing with is uploading your code and your data for the most part, you're uploading your code and storing your data. So that means the networking, the storage, the servers, the virtualization, the operating system, middleware, and all the runtime modules necessary to get it running. It's all done by the cloud provider. So we're typically talking about that and the typical model. And the software as a service model, which is really the three models in your exam, so I'm going to really revert just these three. Basically, the applications as already made by the cloud provider, and the data that the cloud provider manages for you with your data, but it's stored on their systems. They manage the operating systems, the servers, the network, and anything, so you have the least control. So if we look at examples of each, you get your VPC, or your VNet, or whatever you want with which cloud providers, your virtual private data center, what you put in there, your virtual machines, all that stuff, that's infrastructure as a service. Upload your code and it runs, that's platform as a service for the most part. Software as a service is an application that's hosted by somebody else for you. So we think about that. So Let's talk about the key players in the world. There's a lot of cloud service providers. Key players were, realistically speaking, up until recently, Amazon and Microsoft. And we're seeing a lot of movement with the Google Cloud and the Oracle Cloud as well. And I think it's a good thing as organizations do more multi-cloud architectures. For lots of reasons, they're going to be finding themselves on all of these clouds. Most organizations are going multi-cloud here. Organizations started with a single cloud. They realized it was not a good idea. We've never created architectures in the last years where we'd use the same service provider for everything, and I've never seen it before except for some of the early cloud architectures. And when a cloud provider had a failure, the organizations were down and had all kinds of troubles. So there were lots of reasons organizations moved into multi-cloud architecture, 98%. And there's lots of things that we could potentially do. Now, we really need to be a little less concerned about which technology we do and more concerned about what technologies get the business to their actual outcome. So whenever we talk about architecture, it's always looking at it from a non-biased perspective. Can't be falling in love with any technology. We need to basically fall in love with making our clients successful. And you can see that Google Cloud is making big inroads with lots of big organizations, and they're doing great. So lots of organizations are using the Google Cloud. Now, realistically speaking, they're there, and all the cloud providers are going to try to tell you they're different, but in the end, they're only servicing standard data center type things for the most part, and that's what we're really dealing with. So we're going to be in this program discussing the Google Cloud. We'll typically focus on areas of the Google Cloud and principles of the Google Cloud as we talk about designing things for the Google Cloud on the basis of this certification program. One of the core principles, according to the Google Professional Cloud Architect curriculum, is security in the cloud. And a lot of that has to do with the customer data ownership and control. The customer retains ownership of their data, and the customers can control how the data is managed. And it's going to take a lot to really deal with data ownership and control. We'll have to look into things like encryption, for example, and managing encryption keys, and data rights and data classifications, and so much more will go into that. Internal controls and auditing. So another key thing that we're typically talking about that's going to need to actually occur, we're going to need to have internal controls that protect against people doing the wrong things. Strong internal controls prevent unauthorized actions by insiders, and a lot of attacks actually come from insiders, sometimes by accident, sometimes maliciously. And by having comprehensive auditing and controls, we can keep people from doing the wrong things and keep track of people that actually did. Some other things we're typically going to need to be talking about is security monitoring features. How do we monitor the environment continuously for security problems? What kind of real-time monitoring can we do for security threats? How can we proactively identify and mitigate vulnerabilities? And the security architects are going to be doing a lot of work here. And of course, we have to talk about that shared security model. All cloud providers have this shared security model, and here's the reason. You can't control their stuff, and they can't really control your stuff for the most part, or they shouldn't be controlling your stuff. So you are responsible for securing your things. Your VPC, for example, your operating systems on your virtual machines, your firewall settings connecting you to the internet, and they're responsible for securing the infrastructure of the cloud itself. Now, the Google Cloud gives us a lot of encryption options. We can encrypt data at rest and in transit, which is done by default. And we should, no matter where we're at, use strong encryption protocols to protect our data integrity. That we can check the integrity via hash and the confidentiality of our data by encryption and making sure that people won't be able to see it without the encryption key. Now, we also have to understand that all cloud providers have a private network backbone connecting their environment. So we can ride from one part of the world to another part of the world on the organization's network. And the organization's network can have good, strong network performance because they guarantee it and they build it, which is different than routing your traffic on the internet, which is best effort. Now, Google has a lot of control on its infrastructure. Part of maintaining really good procedures are having your systems, having good change control procedures, having a procedure to do everything. And Google, like the rest of the cloud providers, are expert network operators and expert data center operators. So they know how to manage service delivery and can give you a consistently strong, for the most part, user experience. Still expect problems in cloud providers, but for the most part, you're going to get great experiences. So let's talk about some customer preferences as we're dealing with cloud computing. Customers in today's world prefer not to be locked into a single cloud provider. Customers may want to use the various strengths of different cloud providers. Now, there are going to be implications of this when we go through this program. If you want to be able to use a database, for example, and we use a Google-specific database, because maybe, let's say it's the best, we might do that. But if we do that, we have challenges nowhere in that database. By comparison, let's say we needed a NoSQL. By using something like Apache Cassandra, we can put those servers in 3 different clouds. By using something like a Cloud Bigtable, we would need middleware to connect it to other databases and other clouds. So we have to avoid vendor lock-in if we're dealing with multi-cloud, which is going to be not using a lot of the proprietary things we're going to be talking about. So as we go through this, we'll talk about which things are proprietary that are going to make multi-cloud hard, and which things are going to be natural and non-proprietary and open that are going to make multi-cloud easy. And we'll go through that through various components. And Google, for the most part, has a fairly open approach to the way they do things. And I don't know whether it was necessity because they had smaller market share, or, Google came up with open standard things like Kubernetes and help with that. So they do a lot of open standard, open work community, and that's going to be a big help here, specifically when we get to cloud computing. So I hope you understand now what is cloud computing and the various types of cloud computing models that are offered by the Google Cloud.
Okay, well, welcome back. We are here. It looks like there were some really fun, cool questions and discussion points that popped in, which I'm obviously looking forward to do. But I want to just do from a housekeeping perspective. If you just joined us for some reason, there is a completely free guide that's going to go along with this video. It's a good 550-page guide my team made to help you pass the Google Professional Cloud Architect exam, and it obviously goes along with our free Google Professional Cloud Architect training. All you have to do is click the link, sign up, and it'll be emailed to you in 10 to 15 minutes. So keep that in the back of your mind. On Thursday, we're going to have a How to Become an Architect webinar, and we're going to actually talk about what architecture actually is and what architects actually do, and the kind of decisions we have and the skills you need, which in many cases is completely different than certification training. But the questions have popped up, and we'll talk about what it is and what we do and architecture trade-offs if you want. I'll even give you a mini interview if you think you're ready to be hired, or even look at your LinkedIn profile. We're going to do that on Thursday. We hold one every Thursday, so please feel free to join, and my team will drop that link into the chat box as well as the description of this video. Now, and if you're having a good time, give it a like, subscribe, and then let's get to the questions. So Connect Matthew says, can internal IP addresses be accessible across all VMs regardless of a subnet? So Matthew, this is the way it's always been for the last 40 years. All of the internal systems have private IP addressing. The routers and switches route between them. And unless you limit a route or use an ACL or a firewall to block it, normally every system with a private IP address inside of an enterprise can talk to each other. And it's always been that way. So the question is should it be that way? And the answer is no. So realistically speaking, that's where we get into packet filtering, things like access control lists. That's where we get into route filtering. That's where we get into QoS and shaping traffic. Should a server for example, get hit with a worm and propagate too much data, we could rate limit it. So there's a lot that needs to be done. We'll cover some more of those things on the network security days, but what you're describing is the way it always has been, as in almost all systems in the entire world. And even in the cloud, if you've got 2 subnets and you've got routing, or 3 private subnets and you've got routing between them, they're going to be able to talk to each other. So that's the way networking has always been, Matthew. The question is, how do you want to route it and how do you want to architect it? And should it be that way? Good question, though. What drives someone to choose GCP over AWS? So let's be fair. In reality, AWS Google's cloud, Alibaba's cloud, Dell's cloud, the Microsoft cloud, the Oracle cloud, they're the same things. They're buying the same processors from AMD and Intel. They're buying the same DRAM. They're buying the same networks from the same people, the same storage. It's the same thing. So, if you buy your eggs at Publix versus you buy them at Aldi versus you buy it in my village in Nepetamos, it's just eggs. So all in all, they're the same. Now let's talk about the subtleties. Now you will know if you look at Amazon, if you look at their message, it's very startup-y, very small businessy. They don't typically talk about in their public messaging, driving transformation, business process opportunity, business optimization. They always talk about tech. And that tends to get the startup kind of people. Now, when you listen to the way that the IBM or a Microsoft or a Cisco sells, they go to the enterprise. They look at the organization strategy. They've got decades of enterprise experience. They understand business process modeling. They understand this. So Microsoft tends to get a lot of the big enterprise stuff. And if you looked at the last numbers, AWS was struggling in the enterprise, but Microsoft was gaining ground there. Now, if we look at Microsoft and what they've done well, they've invested heavily in OpenAI, and they have more enterprise data most likely than any other company in the world other than Google, because they've owned almost every desktop of the user for decades. Everybody uses Office, everybody uses Microsoft services, and they even own games, so they've got a lot of data. So when Microsoft went early on and was one of the biggest investors in AI, a lot of people see that Microsoft as an AI play too, and it is. It's an enterprise play. Now, if we look at Google, the biggest search engine in the world, YouTube, the second biggest search engine in the world, they've been custom doing and designing AI chips for a long time now. They have so many AI algorithms for decades that are actually out there. So we often think of Google as AI because they're so good at it. So we might think that AWS is small businessy, focused on the techie, make it fun, go build something regardless of whether you need it or not, just go build something. That's AWS message. Microsoft's message is let's be strategic. Let's figure out what you need and how do we build something for you that's going to change your world and the way we live, work, and play like Cisco. And Google's always at the cool end of AI. So you might see that. And of course, IBM, you think digital transformation like Microsoft. So there's branding variations, which typically have different salespeople. The salespeople at Cisco, Microsoft, IBM, those people now to sell billions of dollars of stuff. So that's what they focus on. So it's more of a culture and a marketing thing than technology. It's all the same technology when it comes to a bit on, although there's some subtleties between them. I hope that kind of helps. The other reason is you put all your eggs in one basket. So let's say you're on AWS, you need a second cloud provider. You would never have two networks where your wide area network providers are all the same company. So there's hedging the bets, of course, that. And then the theory would be that Google might be better than AI versus someone else. But it's all theory and conjecture. It's how you design the systems for your needs. Hope that helps. How can we be sure about the security in GCP? They can access your data. They can shut you on your servers. What if they decide? So, as whenever we have to think of architecture and anything, there's always trade-offs. What do I gain versus what do I lose? Now, the key is cloud computing provides agility. But is it as secure as the data center? It can't be. And here's the reason, Yaz. In the data center, you can get hacked. Your data center can be hacked. Now, in the cloud, your virtual private data center can be hacked and the cloud provider can be hacked. So you've got two attack vectors. Now, at the end of the day, Yaz, who do you think is a bigger target? Attacking you or attack Google or Amazon and get all their client stuff? And we've seen in breaches in Microsoft and other clouds where people have gotten into a cloud provider stuff and got a lot of client data. So yes, this is a cause for concern. So some companies and organizations that need high security, like the US government, won't use the public cloud. Now, what they do is they have a different cloud that's built for the US government. So their systems aren't on the same systems as private companies. Hence, they call it the government cloud, because the government doesn't feel it's safe to put their systems in the same systems as the cloud provider. Because imagine if they did. Now they're in the same, all of a sudden you got a couple of countries trying to gang up and get all the information out of a single cloud provider. So think about that. Now, I also was taught something. So I'm Greek, Yaz, and a lot of Greek people open restaurants. And I was given some advice when I was a kid. They're like, Mike, when you open your restaurant, which I never did. My family had a restaurant, but I didn't. They said, when you open your restaurant, you have to buy the building. They said, because if you don't buy the building, and you have a successful restaurant and all of a sudden the landlord wants to triple your rent, you're out of business. So you must own the building. So, we have to think about that. There are times where it makes sense to have your own systems. Now, there are times where it makes sense to have the agility of the cloud to be able to do something in seconds that might take you weeks or months in the data center. So maybe there's times where we want that. So at the end of the day, it's about evaluating trade-offs. Cloud computing offers us agility. It offers speed. It offers us the ability to create new products, new services, potentially, and new things faster than our competition does, and gain market share before our competitor does and gain strategic advantage. It may cost us twice as much. It may not perform as well, and it may not be as secure. No, we can do things to mitigate those things, and we have other training where we talk about how to do that. But the key is, yes, we have to think about this, because it happened to a company like Parler. They were in AWS, and I can't say good or bad for their business, but AWS said, we don't agree with your politics, and poof, they're closed. And then they would have had to figure out how to create a data center from scratch. And that's not easy while you're paying employees and other people. How do you figure out how to start your company all over again? So yes, Josh, yes, it's real. These are the kind of things we need to think about in any time we design. But same thing about real estate. Do we build it? Do we rent it? Do we buy it? Do we rent it? Same discussion. I mentioned servers are separated in the data center, but most people you speak with worry about their information being together. How do you get to communicating this point better? So at the end of the day, Dimitar, all of these are shared systems. If I go to AWS, I may have 10 customers, 50 customers on the same physical server. And guess what? Their storage is also going to be on a similar hard drive. Now, what does that mean if all of a sudden company B, who's on the server that I'm at, does something that is considered to be an illegal crime, and the government comes and they confiscates the server from Google, Amazon, or whatever? Now that government, technically speaking, has access to your data. Some companies worry about that. So same thing with your data. All of a sudden, the government seizes data because they find some companies doing something inappropriate and they need to collect the data, and they steal the hard drives from or they take the hard drives, not steal, from the cloud provider. And then the cloud provider puts new drives in. Again, your information could be there. So what we have to understand is that when we are in cloud computing, it is a shared environment, and ways that we can protect against the shared environment include encryption, network security, identity access management strategies. And we also have to be fair that when we go to the cloud, there are certain security weaknesses that exist in the cloud that did not exist in the data center. Things like perimeters and shared things. So that means we need to migrate to a different security paradigm. I can use defense in depth in my data center, protect here, 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 here. But in the cloud, people are coming from different directions. Now I need to migrate towards a zero trust architecture where I still have my defense in depth, but I need to trust every request, use encryption absolutely everywhere, microsegment everything, because boundaries got weaker. So that's all about your skill, your understanding of the tech, your understanding of the tech's strengths and weaknesses, opportunities and threat. And that's what we do as architects. We say, okay, this architectural option does this and this well, but it does this real bad. This architectural option does this really well, but it does everything else bad. Now, which is the right one for our company? That all depends upon our needs. So hope that helps. Can I talk more about cloud bursting? Absolutely. I love cloud bursting. I think this is the coolest thing ever. So think of it this way. Let's say I have a data center which meets 100% of my capacity. And all of a sudden, let's say I'm selling cat food. And all of a sudden, Taylor Swift sends a tweet that says, everybody likes Mike's brand of cat food. Now, all of a sudden, all these cat lovers and Taylor Swift fans, I think they call them Swifties, they're going to be going to this site to buy this cat stuff. Now, all of a sudden, the web servers will be taxed. They'll be overloaded. So you know what they do? They're going to shift the load to, say, AWS. So when we run out, as we need more server capacity, it could add it to AWS, Azure, Google, Oracle. So we always have more capacity. But we don't pay for it until we need it. That's cloud bursting. What's the difference between serverless and platform as a service? So serverless is a completely garbage marketing term that means there's no server for you to manage. But at the end of the day, it's still everything runs on a server. So I hate the term serverless. So serverless could be upload your code and it runs, like with a function as a service, like a Google function, Azure function, AWS Lambda function. Or it could also be, when we're talking about serverless, a place where you put your containers and it just, and all of a sudden it provides compute capacity, but you don't have to think about the underlying virtual machine. It could be a database that somebody manages the storage and compute for you. So all you need to worry about is your data. That's more of a platform as a service, but it's all serverless. So the key with serverless is it's just a marketing term, which means you don't know where it's running and you don't have control over where it's running. And it's going to run on some server that's there, but that's really it. You can have like an AWS Elastic Beanstalk where you upload your code and then it provisions what's necessary. That's an answer of a more application virtualization, if you will. We can have a serverless database where basically somebody else manages the server, the MySQL installation, you will, the storage, the IOPS, the latency, the CPU and DRAM performance, and all you do is manage your tables. That's all serverless, is that somebody else is managing the underlying thing and taking control over it for you. I think, Chris, we should get back to the content. So I think unless there was anything that I missed, so give me a hashtag Google Professional Cloud Architect to let me know that you're awake, you're alert, and oriented. If you're enjoying the content, give it a like, maybe subscribe, and hit the bell to be notified for new things. And then let's get back to the content.
Now, I'd like to discuss a little bit about the Google Cloud and how it's organized, because we're going to need this when it comes to designing architectures. So let's whiteboard it out. So we're going to have something called regions. And a region is going to be a large geographic area. So let's say we have a region, and it could be the Mediterranean region, a Middle Eastern region, a part of the US, but a large geographic area. And all the cloud providers have their own regions in certain parts of the world. So the regions are going to be a large geographic area. And inside of each region, we're going to have data centers that are actually going to do the work. And typically speaking, you're going to have data centers, and they're going to be called availability zones, typically speaking, or zones. And this is all cloud providers. So whether you call them zones, availability zones, each cloud provider has a name, but I want you to understand this. So in a region, you typically may have a whole bunch of data centers called availability zones. And typically speaking, you might put some of your systems in 2 different availability zones to enhance your resilience to a degree in case one data center fails on others. But we could also look at regions. So without going into any specific regions, let's say that we have a region that's based in the U.S., for example, a U.S. region. Oops. And then we might have another region in Europe, for example. And, for organizations that are going to be limited to a single cloud, which is generally not recommended for high availability needs, they could potentially use two data centers in the U.S. and 2 data centers in Europe. And what happens is these regions are going to be connected by the organization's network backbone. And they're going to typically have some private lines that are going to be connecting their data centers, their regions together. And that's how you'll be able to access systems on both. So think of a region as a large geography, thinking of an availability zone as a data center. Now, what happens typically in networking, and if you were ever going to design large networks, what you would typically do is you would design these networks, and they'll typically have some degree of routing that's common between them, like an interior gateway protocol like OSPF. And then we will have another region in Europe that will have its own interior gateway protocols, its own routing, and its own system design. And then they'll typically run BGP between them. And that way, hopefully, if a problem happens in Europe, it won't propagate across to the US. But it still can, and that's why a single cloud's a single point of failure. Because if anything takes the networking down for the entire cloud, we have absolutely nothing. If anything attacks the cloud's control plane, like in a hacking event, we've got nothing. So network failures, control plane failures, massive hacking or security events can take down a single cloud. So now you know for the most part of how the Google Cloud is organized. Now we're going to discuss some of the principles for design in the Google Cloud. Now, these are the types of principles that are stressed in this certification. Much more is going to go into an actual architecture, much more of understanding the business goals, understanding the workflows, business processes, business architecture components, and all the other systems. But this is some of the things you need to think about with regards to design for the purposes of the Google Professional Cloud Architect certification. One component is really going to be operational excellence. The ability to automate builds, testing, deployment, and use an environment that consistently gets better and accelerates the velocity that applications can be deployed. So the organization can have the best systems in the fastest period of time. So that's a pillar of operational excellence. And along with that means making sure the systems are easy to manage and aren't going to take an incredible amount of resources. And it won't take resources that you don't have to manage those systems. So any good architecture needs to be based upon the business's actual objectives. So prior to starting any architecture, you need to understand the vision for the architecture, what that organization is trying to actually achieve with the architecture. What are the goals? Is it to increase sales? Well, if so, you know what to measure after the architecture is done. Is it to increase the speed that an organization can create code? And that means, the level of code you could produce now versus the number of lines of code later, for example, you could compare them. But you need to know what the goal is so you know what to design for, and then you know what to measure later. This is where you're going to get your metrics, because we need to make sure the systems are meeting the goals of the business. Sadly, in 70% of cases, the systems don't meet the needs of the business or provide business value because they're designed without thinking about the business's needs. So we need to make sure we know what those needs are and be able to monitor the response of the architecture. Did it make the business better? We also need to make sure that we've got a good disaster recovery and business continuity plan for the business. A business continuity plan is how you keep that business up and operational if something big were to occur. And it includes business objectives, whereas the disaster recovery planning is more about how fast can you get the IT systems or the cloud systems or whatever they may be back and up and operational. So we need to make sure that not only is there disaster recovery planning, but on the operation side, somebody tests the plan and works through the planning. Now, in our architecture, we need to design systems that are going to meet the security, the regulatory, the compliance needs. So that means we will need to think about encryption as part of our architecture and strategies, identity and authorization controls, making sure that we've got the right network controls, the right physical controls. It's going to be part of everything. Even applications are going to have to be coded. So making sure we have the elements of a strong security architecture in place for all of our environments is going to be critical. And security isn't just a one device thing. It's going to take a layered approach. And if you can think about an onion, and every time you peel back the layer, there's another layer. That's typically what we want to deal with security. So if you had to get a castle, you'd have a big wall around the castle, and then you'd have a moat around the castle. And then maybe you'd have some knights protecting the castle behind that. So layered security is called defense in depth. And we're going to want to use things like that in addition to a zero trust architecture, typically speaking, when we get there. So that's going to be part of our system design. We need to think about what are the business needs. Does that application or does that system need to run all the time, 24 hours a day, 7 days a week? Can it tolerate 2 minutes of downtime per year, 5 minutes of downtime, or 5 hours of downtime? Because that will obviously govern your actual design and architecture, your actual needs of the system. Now, a lot of security, again, we're going to have to go into here, but that's going to include things like understanding what we're protecting, and every component along the way will need things. So we're going to have to include security monitoring along with all types of monitoring for the system. So what are we really talking about with regards to principles of design? Making sure we design something that's going to meet the business's needs, making sure we have the scalability and the agility in the system so the business can grow or change directions easily without major architectural changes, is making sure we have the security in the systems, whatever's necessary to do that, whether that be a security policy, whether it be an incident response procedure when something happens, whether it be multiple security vendors' products, whether it be a SIEM system, a data loss prevention system, whatever it takes to keep those systems secure, they're going to be part of our architecture. We're going to need to make sure the networking can scale. Anything from IP addressing schemes to route plans are all going to be part of that security architecture. The applications and the way they're designed and how they're designed will be part of that architecture. But all of it at the end of the day is going to go back to, how do we make that business more flexible? How do we make that business more agile? How do we make that business more efficient? And all of that is about aligning an organization's people, processes, and technology. And that's going to be the main elements of architecture. There's not a lot of architecture in this Google Professional Cloud Architect curriculum, and I tried to give you a little more there than that's actually here. But join us on other architect webinars and things. We can dive much, much deeper. And that's what we do in our primary training programs, is deal with the 1,000 hours of training that are necessary to answer those questions. Now, we'll move on to a new topic, hybrid and edge computing. And that's going to be something we typically deal with in the modern environment. And hybrid cloud computing and edge computing is quite nice, and we'll talk about why we use these things. So, a hybrid cloud, often called hybrid computing, combines the benefits of a data center and the benefits of a public cloud at the same time. Now, hybrid computing has a lot to offer. And why is this? Because in our data center, we have the maximum control. We have the maximum performance. If we want to think about going from the data center to the cloud, there's going to be latency. And that latency may or may not be best upon the applications. In the data center, we have almost no latency because it's right next to us. When we go to a cloud provider, those systems and the cloud provider could be 1,500 miles away. So there's going to be several milliseconds of latency, which can affect performance. Does it matter? It depends on the application, but we need to be able to think about it. The next part of the data center, which is so good, is high performance workloads are much cheaper in the data center than they are on a cloud. For example, you can find cases where a $300,000 server from one of the server vendors like Dell might cost $5 million to run that same identical server over the cost of 4 or 5 years in the cloud computing environment. Now, it doesn't make sense to spend that much more to put that server in the cloud. Keep that server in the data center. But you know what? The agility, the flexibility of the cloud provide a whole lot of business value, and we might want to use both. So in hybrid computing, what we have is we have the data center. We've got all the data center benefits, and we still have the benefits of the cloud, and we can do all kinds of things. One thing we could do if we wanted, we could put 50% of our workloads in the data center if we wanted, and we could put the other 50% of our workloads in the cloud. And just imagine, for example, if we did that, we can monitor the data center. And if for some reason this data center went down, we could use auto scaling in the cloud to bring that 50% capacity to 100% capacity within 45 minutes. So that would improve the availability of the system if we wanted to do that. Now, there's a lot of things we can do security-wise in this data center that we can't do in the public cloud. I can create my own VLANs. I can create access lists at layer 2 based upon MAC address. I can create a special kind of VLAN called the private VLAN, where 2 servers in the same subnet in the same VLAN can't even talk to each other. I can create controls that if you plug in with the wrong MAC address, the port that you plug into is shut down. And I can even create quality of service to prioritize mission critical business traffic over, for example, worm traffic if it was on our system. I can do that in the data center. None of that can be done in the cloud provider. Why? The cloud provider may have 100,000 other clients in their data centers, and they need standard networking. And in your data center, you're the only clients you can do this. So the hybrid cloud will give us the best performance, the maximum performance, and we still get the agility, scalability of the cloud. And we can do one other thing here, which is called cloud bursting. And this is absolutely incredible. So let's say right now, we basically kept the majority of our systems in the cloud. Let's say all of them for right now. In a hybrid cloud, what we can do is we can have this connection to the cloud provider. And if the applications reached a certain level of utilization, We can immediately add capacity in the cloud provider and just pay for it as we're using it. When we no longer need the capacity in the cloud, shut it down and then resume to our servers, which we already paid for in our data center. So a lot of powerful things we can do with hybrid cloud. Now let's talk about edge computing. Edge computing is something pretty cool, and edge computing is getting the computing processing power closer to the user. So you might, let's say, in your house have a computer. It's fast for you to access it. But if you had to get your data off of the cloud or you had to access a server on the cloud, it might take milliseconds of latency because of the latency between you and the cloud provider, much longer over the internet. But what if you needed that information to be processed as fast as possible? Do you want to take that data over a long network? Probably not. So let me show you this. In this environment, what we have is we've got some edge computing going on here, and I'll show you why the latency matters. So let's say we had a self-driving car, and the self-driving car was going to be communicating with the data center, potentially to be making decisions or gathering information. If the car sensed an obstacle and sent some information to the computer, you want it to get to the server, you want it to get back as fast as possible. And if it took an extra 1/100th of a second to get the information to a cloud server for a self-driving car to give the command brake, maybe that's the difference between hitting something and not hitting something. Not usually the case, but we need that latency to be that low and that fast. Imagine a surgical robot, for example. And the surgical robot that's outside in the field needs to get a command to stop cutting. And we need that instantly. So getting it closer to the server, as opposed to backhauling it to the cloud provider, which could be 1,500 miles away, gives us better performance. So this concept of edge computing and putting the compute power closer to the user can really help with a lot of different applications that are out there, reducing the latency of these applications, and it enables some new things. So to me, edge computing is pretty exciting when we start thinking about all these IP type enabled applications we can actually do for the future. Now, you'll typically also hear about Internet of Things with edge computing, which is something you'll also see among cloud providers. Internet of Things typically are Internet IP-enabled sensors, like your refrigerator or 101 other things. And cloud providers often have management software to manage those devices, host those devices for you, and sometimes under some cloud provider circumstances, you can run that at the edge of the system as well. So now you know about hybrid computing and what they are and why, as well as edge computing. Now, Google has this Anthos, which gives you a unified platform for managing your hybrid environments, and it enables some fairly consistent deployment, operations, and security policies across these. There are many other ways you can manage a multi-cloud architecture, but it is a Google certification exam, so you need to know about GCP's Anthos for that reason. And Anthos is going to be that Google's solution for managing your hybrid and your multi-clouds. It's going to simplify realistically modernization of things by enabling developers to use a single platform to deploy and scale containerized applications across the environment. It's built off of Kubernetes, so it enables the organizations to be able to deploy and run workloads across data centers. So when we start thinking about these services together, they make it easier to deal with multi-clouds and hybrid multi-clouds, which is the reality for almost everybody. 89% of businesses, the last time I checked, were running on multi-clouds. And according to Oracle, 98% of enterprises are multi-cloud. So we'll always have to think about ways we can manage and optimize these multi-cloud environments and put the compute power where it's going to be best served to the application, and edge computing and hybrid computing are environments for that. Now, Google also has something called an edge TPU. So Google came up with this tensor processing unit to basically assist with AI and machine learning loads. It's the specific processor that Google actually has. Often we use things like NVIDIA GPUs and CUDA to also run our operations, but this is an alternative that you can do on the Google Cloud. And Google has these TPUs at the edge of your device, at the edge of their systems, at the edge layer to promote very rapid processing, potentially of AI and machine learning workloads before going to the actual data center. So it's really going to reduce latency. And that can reduce bandwidth. It's going to be backhauled to the data center, which can also reduce costs. So I want you to think about this. in an environment where we have like this, where we've got our devices, if they can hit the edge server and back, we only have the networking to contend with from the mobile device itself, or the automobile, or the robot, or whatever it is, to the edge node. We don't have to think about the networking between the edge node and the cloud for the most part, because the work is already being done here. If we had to send it back to the cloud server, not only would we have the latency of the systems, but now we'd be dealing with bandwidth that we might need to deal with and or pay for, depending upon the architecture of your environment to the cloud server. So there's a lot of benefits from keeping the data and the processing of data, even AI. Let's talk about other reasons. In certain cases, we must have data locality and compliance. So many industries, like healthcare and finance, are subject to very strict data resiliency and compliance regulations. And a hybrid model makes it easy for an organization to process and store sensitive data locally, as opposed to it getting replicated over a cloud provider, potentially speaking, all over the world. So we can have the ability to put mission critical, more private data in our data center and put less risky data in the cloud, should we choose to, because we can, again, get more control in our local data center. And with Google's Anthos, it can help you balance the integration between the on-premise environment, the cloud environment. So that's going to make it easier to maintain compliance and benefit from the scalability of the cloud, the agility of the cloud, and still keep your systems running in the data center, which are often going to run better, faster, and cheaper for high-performance workloads. So that's really what we're talking about this. Now, we can also do a lot of disaster recovery with hybrid computing as well. By disaster recovery, we could either use the cloud as a disaster environment, where if our primary data center went down, move it all out of the cloud if we wanted, or we can also use the cloud to disaster recover another cloud. So we may have our systems on AWS. I don't want to put my disaster recovery systems on AWS if my systems are hosted on AWS, because if AWS is really out for some reason, then my backups, who knows what's going to happen in a disaster recovery environment in AWS. But if AWS is hacked, chances are that Google or Azure won't be at the same time. So that's why we want to use disaster recovery in another cloud. And let's talk about the kind of disaster recovery we can do in cloud computing that makes it so much more efficient and so much cheaper that you might actually think about. So we might have our data center here. And realistically speaking, let's just say we had 100 different applications, and each application had 10 servers. So we had a total of 1,000 servers, right? In this particular environment. Now, what if that went down? And what if we didn't have what if we had 2 data centers and they weren't all go down? Now, we have a couple of options with the cloud provider. So we have a few ways that we could back it up. And I want to show you why these are different than any other way. So if we had this traditional environment, we ultimately had the choice of having a physical disaster recovery site that either was maximally staffed like this, or maybe it could support 10 of the applications, maybe at 100 sitters and servers waiting to go there. And if and when this were to go down, the disaster recovery environment would support a subset of our business. And this was complicated. We had to buy gear ahead of time. We had to spend a lot for real estate. So this was pretty expensive. Now bring us to cloud computing. We have a couple options. One option that we can do here is if we have 10 servers, we can have 10 images of our servers. And we'll talk more about images later, but we could just have 10, let me just make it bigger so you can see it, 10 different images. And an image is a bit by bit copy of it, of a server. We could synchronize our data periodically if we wanted to, and synchronize the data with the cloud. And if this was the case, worst case scenario, if our data center went down, all you're dealing with is paying to store these 10 images and your data, and we could have a cloud engineer open an infrastructure as code script and, literally speaking, replicate your entire environment, and it would be up in about an hour or so capacity. And the only thing that would be questionable would be how long you backed up your data. Now, in the cloud, we can make it a little better. We could synchronize our data in real time if we wanted to, and let's say we synchronize our data/databases. DB. Now, if we were to do this, and this is, for example, why hybrid clouds are often used for disaster recovery, here's what would happen in a failure. We already have our data absolutely synchronized. We have copies of our virtual machines. Somebody launches an infrastructure as code script, and wow, depending upon how good that organization is and how fast their scripts, in 30, 45 minutes, they've got a full operational business. And all they were paying for was 10 images and synchronized data. So that, again, could be really cost effective. But here's where cloud computing really shines. So if we really wanted good automated disaster recovery, we have these 10 application servers, right? We have in the main data center, we have 100 application servers. And they all take 10 servers each, right? So what if we had one server for each app running in the cloud, which would mean 100 servers? So this is a server, and they're all running. We just have all these little servers running here in the cloud, one instead of 10, and all this is here. So now we've got our data, our database synchronized, and basically 10% of our capacity sitting in the cloud. Now, what's great about this in a hybrid cloud is we can have a system detect a failure. And if the entire private data center were to go down, we could redirect all traffic to the public cloud. And these servers can use auto scaling, and they're going to be up and operational instantly, but they'll be at reduced capacity, say 10% capacity. And automatically over the course of 45 minutes, this thing is going to be 100% unoperational because the servers will just scale out based on need. And this is where the cloud really shines, especially in these hybrid type architectures, but honestly, in any kind of architecture you might have. And of course, our last option is to just run an exact copy of this and here. But that gets pretty expensive because if we have 100 applications with 10 servers, that means we need the same 1,000 servers in the data center and the cloud running at all times, and that gets expensive. So I hope that makes sense from a disaster recovery, business continuity planning. I hope it's actually making sense of why we're using these varied architectures like hybrid computing and or edge computing.
Okay, I've always loved the cloud computing disaster recovery options, just the ability to just create something and let it kind of almost happen automatically. I've always thought that was cool. But in any case, let's see if anybody has any questions. Reminding everyone now's a chance to ask questions on what we've discussed as it pertains to this Google Professional Cloud Architect curriculum in this course to prepare you for the Google Professional Cloud Architect exam. Not sure if any other questions popped in, but if they did, we're happy to address them. I'll give everybody a minute to do so. While we do, I want to remind everyone that we've got a completely free study guide that you can sign up for. Chris from my team will drop the link to that in the chat box. And basically, that link will basically give you about a 550-page book of notes to help you pass the exam that's going to go along with this completely free training. So go sign up for it. If you sign up, it may take 10 to 15 minutes to get an email to you. Please do note that. Thursday, we have a completely free webinar. And we'll go over how to become an architect. You can join us that as well. But also to let you know, remember I said today was going to be a big day. We've got about 70 minutes of content and a couple of labs. We wanted to start the week big. We wanted to go heavy Google. And then for the most part, everything else will be for 3 to 3.5 hours each day, other than most days. But we'll have a nice little fun lab on some simple things like creating an account and setting up a budget after we go over the content. So hope to see more of you. Ask some questions if you have them, and let's have some fun with this Google Professional Cloud Architect materials. While you're at it, please give me a hashtag GCP or a hashtag Google Professional Cloud Architect. And if you're having a good time, give it a like. Maybe subscribe to our channel and hit the bell. And I'd be curious to know where some of you are. If you have a chance, just let me know in the chat box where you're at. I know that some people are in certain parts of the world based upon names, but I'm always curious to know. Let me know. So there's no questions right now. So if you ask any questions after we start the next video, we'll just answer them then. So let's get back to the content, Chris.
What we're going to do now is we're going to provide a high-level introductory overview of the Google Cloud services. And then what we're going to do is dive deeper in other sections on each of these main components that we'll be using in the Google Cloud. We want to make sure that you basically understand the primary services, what they are, In many cases, we'll compare them to other services from other cloud providers to help you in your multi-cloud knowledge as well. And we want to help make it easy for you to learn these services. And sometimes if you're familiar with them, we'll point it out over here. It'll automatically make sense. And then when we dive deeper, then you'll learn the Google specificness of the way they implement these various services that have been around in pretty much every data center and every cloud provider. So that's what we're going to talk about in this section. Now, understand if you're a cloud architect or a solutions architect or any architect for that matter, we're most likely going to be dealing with multi-cloud environments. 98% of enterprises, those are Oracle's numbers, and they're pretty accurate. So most cases we're dealing with multi-cloud. And that's where we're going to try to introduce these at a high level first. The first thing we're going to introduce is something called Compute Engine in Google. And Compute Engine is nothing more than a virtual machine. It is infrastructure as a service, and it is virtual machines. So it's not going to be any different than the AWS EC2 instance, the Azure virtual machine, the Oracle virtual machine. It'll be like any other virtual machine that we would deal with, where we can get a predefined virtual machine, typically speaking from a cloud provider. We can basically take this virtual machine, install anything we want on this virtual machine, just like the same virtual machines VMware invented in 1999, that hypervisor that we've been using in the data center for decades. This is the same thing, but it's the cloud provider's hypervisor. The next thing that we're going to talk about is something of this platform as a service from a compute perspective, and it's Google App Engine. Again, we're just introducing them now. And the point here is that it's a serverless application platform for deploying applications. So all that's really necessary is the developer has to write their code, they upload the code, and then it's going to run in this application virtualization environment on the cloud provider. The developers can write in Go or Ruby or PHP or Java or Node.js or Python or C# or .NET. It's pretty flexible with regards to the programming language. The developer uploads that code and the infrastructure is provisioned and is there and it's automatically waiting for you. Application virtualization. You might think of AWS Elastic Beanstalk. It's something fairly similar. Now, you're also going to understand that one of the ways we deal with compute could be in a containerized environment. And Google has a fully managed Kubernetes environment available for you. It's a platform as a service, a Kubernetes control plane that's pre-set up and pre-managed. And this is an enterprise-ready containerized solution. There'll be pre-built deployment templates. It'll simplify licensing. It'll consolidate billing. There's all kinds of great things with this. There's also some architectural challenge with this. For example, if your control plane is Google and your other systems are on AWS and your data center and Google goes down, you lost your control plane across other cloud providers. But this is a platform as a service ready option for you. Whether the business can use something like this or they have to use something like IBM OpenShift or Red Hat OpenShift will be based upon business needs. But the Google Kubernetes engine is very similar to the AWS Elastic Kubernetes service or the Azure Kubernetes service as basically managed Kubernetes where the provider is doing the management of it for you. So with Google Kubernetes engine, we're typically going to have the same master nodes that we would have anywhere because we're dealing with the same Kubernetes that we always have. It's just going to be managed for you. So we'll have the API server that handles all the Kubernetes API requests. We'll have the controller manager, for example, that will monitor and maintain the cluster state. We'll have the scheduler that will assign workloads to pods and worker nodes. And of course, we'll have that etc.d that's going to store the cluster data, if you will, and other things. We'll have the worker nodes, like which is where the application is going to be running, which means we'll have the kubelet, which manages communication with the master node and runs the pod. We'll have some kind of container runtime module like Docker or Containerd on the worker nodes to make them run. And we'll typically have some kind of a kube proxy to manage the network communications. And this is going to be managed for you. And that's the strategic advantage of these types of services as they are managed. But we also have to understand that there's going to be some various complexities that are going to be associated by only dealing with a control plane from a single provider. But I'll show you what it could look like so you can understand it. Here's your high-level Kubernetes overview. You have the control plane that's basically dealing with everything that needs to occur. And then you have the data plane, which is the work is done, which is on these nodes themselves. The next type of compute option we have in Google is something called Cloud Run. And that's another platform as a service offering, which means it's fully managed compute. So you don't have to think about managing the infrastructure, managing the number of servers you need. You're paying for the resources that you use. And this is where you're going to be able to put up standard containers, standard type software. And it's a lot like the AWS Fargate. So instead of hosting it on a virtual machine, now you're hosting these containers in a fully managed environment for you. So you might use Kubernetes as a control plane normally, and then host your containers on a virtual machine. And you could do that in any cloud, or you can use Kubernetes as your control plane. And here you can use Cloud Run to manage to run your servers on. In the same way you could use Kubernetes with the AWS Kubernetes service, the Elastic Kubernetes service, and Fargate to host your containers. It's the same concept we're talking about across clouds. The next option of compute we typically have in cloud computing is something called function as a service. This is a little piece of code that you upload and it's going to run on a server somewhere. You just don't know which server where, and you don't have to worry about it. So we typically use these functions that if this happens, do something else. So they're typically great for light workloads, sporadic workloads, things that don't happen quickly. For example, somebody puts an object into object storage, whether you call it cloud storage, and set the permissions to public or open. You could do that on AWS, Azure, or Google and immediately cause a privacy issue. So you could have a Lambda function or an Azure function or a Google function monitoring something that looks like that and immediately responding and fixing the permissions for you so you don't have a security breach. That's typically called an event-driven architecture or an event-driven compute platform, allowing code to be run on a server where you don't know which server it's run because all that abstraction is done for you by the cloud provider. These functions as a service scale up, scale down anytime you want. Again, Lambda function, Azure function, Google function, function as a service, which can also be done in Nutanix Cloud, OpenStack Cloud, that kind of thing. So storage solutions in the cloud. Just like any other data center, a cloud's going to have storage. So what does that mean? We'll have object storage, for example, which is just like we would in the data center, and Google calls it cloud storage. It's the same as AWS S3 or Azure Blob. It is object storage. So we can do all the same things with the Google Cloud. We can set up for lifecycle management, cost optimization, where we're going to move it to the right storage tier, for example. We can use object storage for backup and archival purposes, typically speaking, software distribution. So Google, for their object storage, has various levels of availability for that. Anything from 99%, which is not exactly high availability storage, all the way to 99.95, which is getting into moderately high availability storage environments. Now, we also have something called Cloud Firestore. And what is that? It's file storage. So no different than any other file service that we've worked with in an environment. But it is a hosted and managed file server. So you don't have to set up and manage your own server. So normally speaking, what you would do is if you had Linux, you'd set up a server, you'd create an NFS share, and you'd have to manage all of that stuff and manage the servers and the drives on that server. In this particular case, it is very similar where the provider has a server for you and all you do is create a share and it is on their fully managed servers. So that's typically speaking file storage that you could use. And it's basically network attached storage. And of course you can use it and attach it to virtual machines if you've got a lot of virtual machines that need access to the same data at the same time. So again, file storage, no different than NFS you would use in your data center. AWS has their elastic file storage, or you could set up your own file server and share the drive. It's the same kind of thing that we're dealing about. Now, we also have something called the persistent disk in Google. And a persistent disk is block storage. And we're always going to be using block storage as a virtual hard drive in cloud computing. So They call it persistent disk. AWS calls it elastic block storage. Who cares? It's all block storage. It works the same way all block storage environments do in all data centers for the last few decades. Now, of course, when it comes to block storage environments, they can be based on magnetic hard drives, SSD drives, or NVMe drives, and that will determine its performance. But this is just going to be any type of virtual machine type storage where it's block storage. You can resize on demand. You can back up your storage volume into an image. Traditional block storage used by virtual machines in the data center, now used in the Google Cloud. You can attach it to a Google Compute Engine or instances or any of your Kubernetes pod instances you would be using as well. Now, we're going to have multiple storage options there, which we'll get to at some point during the program. Google has a bunch of databases that they've made for themselves. One of them is Cloud Bigtable. And what is Cloud Bigtable? It is a fully managed Google NoSQL database that can handle millions of requests per second and provide consistent sub 10 millisecond latency. So where would you use a big NoSQL database? You typically use it on many environments where you need with scalability and unstructured data. For example, storing where you're at in a video game or a player could be in environments, social media environments. You could be using wide varieties of NoSQL databases, massively scalable databases. And if you really look at it, it is the Google version. And it integrates relatively easy with the Apache Cassandra ecosystem, which is a great thing. So you may hear of Microsoft has Cosmos, Amazon has DynamoDB, and Google has Cloud Bigtable. Now, if you're in three clouds, maybe you're better off using MongoDB, for example, or Apache Cassandra, because that's going to better fit in your three-cloud multi-cloud environment. But this is the Google hosted. Basically, they run things, and all you have to worry about is you and your data. Now, the same we can talk about is Cloud SQL. They are fully managed relational databases on the cloud. And they support many of the databases you typically would think of, MySQL, PostgreSQL, SQL Server, that kind of thing. And that's going to make it relatively easy because these are standard relational databases. And this is very similar to any other cloud provider's database management systems. AWS calls it RDS, Relational Database Service. Same thing we're talking about here. Now, we can also talk about Cloud Spanner. Cloud Spanner is going to be a fully managed, scalable relational database maintained by Google. They support regional and global distribution of application data. It provides a good, strong relational database structure and horizontal scalability. Yeah, because it's a relational database, it's got strongly consistent reads, and it typically flows with the rows and column type environment that you typically think with any other relational database. Very structured. Now, when we're dealing with here, you've got something that's going to give you good features type functionality, typically a little better than what you get out of one of the freeware databases. These are typically a little less than what you would typically get out of, say, an Oracle database, which is a paid database. But Google's got a lot of expertise as it pertains to databases. So it's a great relational database, but remember, 98% of organizations are multi-cloud. So using Amazon Aurora, it's the same kind of concept. It might lock you into challenges later. So keep that in the back of your mind. If you're going to be in multi-clouds, which you most likely will be, use something that works in all clouds. Now, Google also has something called Cloud Firestore. That is another fully managed serverless NoSQL document database that you don't have to think about, designed for mobile, web, and IoT applications. So it typically has great scaling capabilities. And it's kind of the next generation of data store, if you want to look at it that way. It's got good availability at 99.999%. And again, this is going back to an Amazon DynamoDB kind of thing, Microsoft Cosmos kind of thing. So while Firestore is more optimized for mobile applications where Bigtable is more analytical workloads. But here's the thing. If we use these, what's going to happen in multi-cloud? There's non-proprietary databases we can use in all clouds. Now, when it comes to databases, we often need caching to improve our performance, scalability, that kind of thing. So we typically use a cache. And when it comes to caching, we're typically using one of two kinds of caches, either a memcached cache or a Reddit cache. And what are we dealing with here? Google's memory store is a hosted cache, which you can use with a Redis cache or memcached. So realistically speaking, pre-made cache that you can use, 99.9% availability, which is a pretty strong SLA for a cache. And you may hear of Amazon Elastic Cache. Same thing that we're trying to deal with in that environment. Now, Google has a great data warehouse solution called BigQuery. It's serverless, it's highly scalable, it's relatively cost effective, it's great at big petabyte scale data. There's not a lot of operational overhead. And it's based on Google's Dremel query engine. It's got good availability, 99.9% available, and it's unique in the industry. This is pretty much unique to itself. It is a data warehouse. Now, AWS does have their data warehouse that they also have, but this is a big data warehouse and an analytics solution. So it's a little different than the others, but very similar to the AWS. Drawing a blank on, I can't think of the AWS data warehouse name right now, but that's what we're really talking about. Again, there are data warehouses like Postgres, which we can put in every single data center and every single cloud. So we have to think about it. Now, when it comes to big data environments, we're going to be working with data, mapping it, reducing it, changing it, cleaning it up, and lots of things. So we typically need some tools for that. Google has a tool called Dataprop. It's very similar to AWS's Elastic Map Reduce and AWS Batch. It's a fully managed Apache Spark, Hadoop, Presto, and other big open source big data environments. But in this case, you're not running your own servers. You're basically paying when you're using it. It's pay as you go per second pricing, fully managed for you. Now, we also have Dataflow, which is going to be a serverless stream and batch data processing service. I hope you're already thinking of the other clouds and what they already do. And basically, you're dealing with streaming data. So typically speaking, in a multi-cloud environment where we can't use anything proprietary, we have Apache Kafka here. But this is very similar to Amazon Kinesis that we're talking about when we talk about Dataflow. No, we have to be able to deal with messaging type systems and event messaging type systems and queuing systems. So, we've got these pub sub messaging environments. And of course, Google has one too. They call it pub sub. There's no provisioning required because it's managed for you. It's available 99.95% of the time from an SLA perspective. And it's going to sound a lot like Amazon SQS and SNS, those types of environments. Now, Google gives us some data analytics solutions, which is great. There's something called Cloud Composer, which is a fully managed workflow orchestration service. It's built on Apache Airflow. It simplifies the orchestration of authoring, scheduling, and monitoring pipelines across your clouds and your on-premise environments. It's going to feel a lot like AWS Data Pipeline and to some degree AWS Glue. Now, we're going to be dealing with, let's talk about how the cloud is laid off. So generally speaking, anything in Google Cloud, you have the ability to reach it globally, assuming you set up the networking correctly. And what we have is we have an environment where we have regions, which are big geographic areas. And then what we'll have is zones, which are little data centers inside of these areas. So that may sound fairly environment to you, simple and fairly familiar to other cloud environments with you that we're dealing with this. And I'll show you a visual representation of what we're actually talking about here. So normally speaking, you might have a large geographic area. And this is, in the blue is the entire Google Cloud. You'll have a region, which is going to be maybe like the US or a continent or half of a continent. And then we'll have these little zones, which are data centers inside of those. So think about the Google platform being the entire environment, the region being a big geography, and a zone being a data like an AWS availability zone. I think Azure calls them availability zones as well. So that's typically what we're talking about. So you understand the way the cloud's laid out. And we will typically have something called a virtual private cloud, which the virtual private cloud is going to be our virtual private data center. We'll get our own we'll get our own virtualized network environment, which will come with virtual routers, which will give us things like the ability to create ACLs and packet filters. Inside of these environments, we will create our subnets. We will put our servers. So we'll set up our own virtual private data center. And they call it a virtual private cloud. AWS calls it a virtual private cloud. Azure calls it a virtual network VNet. I like to call it my virtual private data center because that's realistically speaking what we're talking about. Let's talk about some other networking solutions provided by Google. They provide DNS services for you, fully managed DNS. And they've got reliable, low latency DNS services. Google is known for high availability and great DNS services. Typically, they use Anycast, and you'll see their DNS servers is 8.8.8.8. They might even be on your computer because so many people use Google's DNS. But this is a hosted, fully managed DNS service for you. They call it Cloud DNS. Very similar to AWS Route 53. It's just managed DNS service for you. Now, we're now going to talk about VPC flow logs. So we may want to see how traffic is going from point A to point B in our network, which packets are getting filtered, which packets are not. And in the old days in our data centers, we'd use about 20 years ago, Cisco had something called NetFlow. And it would give you good information about your network traveling through your environment. We used it for network monitoring, forensics, security analysis, cost optimization, figuring out what was going on in our network. Guess what? We can use it on the cloud. We get what's called VPC flow logs. We can analyze this. Now on the cloud, we're going to pay for it, and it's going to get expensive pretty fast. So we don't want to leave it on all the time. Typically speaking, we want to use it when we need it. Not always, but generally speaking, we want to use it when we need it. But in the data center, it's free. So understand, if we are hosted on the cloud versus the data center, we're going to pay heavily to get these types of things. Now, we also have some other networking solutions from Google. We have the Cloud Firewall, which is actually a great next generation firewall. They've gone so far to use the Palo Alto intrusion detection and intrusion prevention systems, which is absolutely fantastic. It'll allow or deny connections based upon deployed rules. It's obviously stateful, and we can configure any kind of good next generation firewall options with this. Here's the problem. We're going to typically dealing with a multi-cloud architecture, and it's going to be very hard managing different firewall platforms. And if we use something like a Palo Alto firewall, a Cisco firewall, a Checkpoint firewall, or a Fortinet firewall, we can put them in all clouds and we don't have any of these interoperability issues. But if we're only on the Google Cloud, that cloud firewall is an excellent firewall for cloud computing. And we also will need content delivery networks, and there's a wide variety of them out there. Akamai is a huge player in the content delivery network space. Cloudflare is a huge player in the content delivery space. All the cloud providers have their own content delivery network. For example, AWS has CloudFront. Fastly is another content delivery network provider, and you typically need more than one content delivery network in very high availability systems. But a content delivery network is going to be a network of caching servers and a network and caching servers that's going to push your content to the edge of the systems. And that is going to cache content at the edge, which will typically enhance the scalability of your systems. It will reduce the workload on your systems. It will reduce the latency to your customers. And content delivery networks give us great options to protect against distributed denial of service attacks by blocking illegitimate requests at the edge of the network. So lots of content delivery networks that exist out there. Google's is called the Cloud Content Delivery Network. Amazon's is called CloudFront. And then there are much bigger content delivery networks that have much more points of presence throughout the world, like Akamai. Now, when it comes to any data center, we're going to need load balancers. Guess what? In the cloud, we need the same load balancers. In the data center, they're physical load balancers. We often get them from F5. In the cloud, we use the cloud providers. So Google has the cloud load balancing service. and that is a fully distributed, high-performance, scalable load balancing service. It offers Anycast IP for global backend instances to support HTTPS, TCP, SSL, TLS-based traffic, UDP traffic-based load balancing. It can handle multi-region failovers and internal load balancing. So a lot of load balancing features that you've got. Cloud load balancing. Google also has NAT. In many cases, in an organization, we're going to have to take our internal private IP addresses and translate them into public IP addresses. We typically do them on a router or a firewall in a port overload address translation manner. And Google has a fully managed NAT service for you to use that's managed on translation of your addresses. It enables you to keep applications that don't have public IP addresses to go out to the internet and update their operating system or patch themselves without being reachable from the internet. And that's the key. It enables you to go out to the internet to update your systems, but you're not reachable. So it's like an AWS NAT gateway, of course, firewall, if you could do NAT with as well. So we're going to talk about Cloud VPN. And a Cloud VPN is basically creating a VPN to connect either your on-premise environment to the cloud or connect to AWS Cloud to the Google Cloud over an IPsec tunnel, for example, over the internet. Now, the key is VPNs don't get that fast with the cloud providers. Our IPsec tunnels can give us up to 3 gigabit a second, which is pretty good, but not super fast. If we need 10 gigs or 100 gigs or something better, we're going to have to use a private line. But this is just an IPsec VPN. AWS has something called the AWS Cloud Client VPN. It's pretty much the same environment. And we'll talk deeper about most of these things throughout this program. We also have a cloud interconnect. And what that really is a private line between you and the cloud provider. That's it. And you can get a dedicated interconnect, as they would call it, or a cloud interconnect, and it is a private line to the cloud provider. That's all it really is. If you need, you can get it directly from a service provider like AT&T or Verizon. You can also go through a third-party port, or typically speaking like Megaport, to go to these various cloud providers. And there's lots of third-party providers. The service level agreement we would get will be based upon the connection type, but here's what I want you to understand. When we use the internet for a VPN, we have no guarantees of performance because there's no guarantees of performance over the internet. When we use cloud interconnect, it changes a lot of things. And the reason it changes a lot of things is it's a private line. So it's going to give us guaranteed performance. So if you want to think about AWS Direct Connect, if you want to think about Azure Express Route, this cloud interconnect, this dedicated interconnect, is the same thing that we're talking about. Let's talk about some networking solutions in the Google Cloud. Typically speaking, we're going to have something called peering. And peering is when you connect one network, basically speaking, to another network. And you can use direct peering where you peer to them. And there's also called carrier peering. But what we're really doing is getting you access to the Google Cloud where you're going to exchange routing information, typically speaking via BGP. We can also connect various VPCs together for an environment. So what do we mean by that? We might have, for example, 2 different VPCs, VPC A and VPC B. And we might want them to be able to talk to each other. Now, there's 2 ways this could occur. One way is let's pretend this was the internet. We don't want to do this, and I'll talk about why. One way is we could take our traffic, leave our environment, go out to the internet, cross the internet, and then go back to the next VPC, and obviously do encryption and everything that's necessary. But here's the thing. In order to do this, we had to leave the cloud provider's network, go to the internet, come back from the internet onto the cloud. Now, we're already, and there's no guarantees of performance on the internet, but we're already on the cloud provider. So VPC peering basically creates a private networking connection between 2 of your VPCs and the environment. And that's what your VPC network peering is enabling you to do. So in this peering environment, you can use private IP addressing. You're not using the public internet. You've got greater security by avoiding the public internet. You can still encrypt it. You've got reduced latency. And in some cases, you've reduced your egress fees depending upon what's being billed by the cloud provider at the time. They're always changing these things. And we have some private Google Access options as well. For example, we can keep our virtual machines with internal IPs and they can still access Google services, which is great. They don't have to go to the internet to access Google services. We can have Google access to on-premise hosts if we've got a connection between us in a good networking environment. We can keep our VPC networks and connect them to other Google services. So we've got a lot of abilities with networking on Google like we do any cloud provider, because what is a cloud? Renting space in someone else's network and a data center. Welcome back, everyone. We are here. Admittedly, I know this is a long intro to what is cloud computing, but we really wanted to give you a kickoff at a high level of Google services. And then we'll spend the next kind of 2 weeks diving deeper into these concepts to make sure you can easily pass the Google Professional Cloud Architect certification and understand this material. So that's what we're doing so far. Bear with us. We've got another fairly long video. And after that, we've got a couple of very soft, fun labs like creating an account and creating a budget. So that's what we have. I think I saw maybe 1 or 2 questions pop in. I'll address them and then we'll get back to the content. I want to remind everyone that tomorrow we should be starting with identity and access management. The day after that, for the next 2 days, we'll have some fun in networking. I absolutely love networking. Without networking, nothing works, and networking is important. So we'll spend a couple days on networking, and then we'll do compute on Friday, where we'll dive deeper into the options that are available on the Google Cloud. So we have lots and lots of fun stuff coming. So Chris, I think I saw maybe 1 or 2 questions that popped in, and I want to make sure I address them. I think there was one. And I think it was from Devel. So, okay, so the question was from Darnell. And he said, besides the boot camp, what other resources would I recommend for the Google Professional Cloud Architect exam? Now, Darnell, I have to say, I really like this book from Cybex. I can tell you that when I took the Google Professional Cloud Architect certification, well, 2 things. One is obviously I've been in cloud computing since I've worked with cloud since 1993. So there was nothing new about cloud computing, but I was able to take my cloud computing expertise and designing clouds for enterprises for decades, decided to say, hey, I wanted to see what a cloud certification would be like, bought this book, and shortly after took this Google Professional Cloud Architect exam, and it was very straightforward. So I do like that book. I could generally recommend a practice exam as well, but generally speaking, I do like that book. I would take our course. I would use that book. The book is the official curriculum from Google. What we're doing is fairly similar as well, but we're starting from the top at a high level, and then we're diving deep into everything else as we go along. But I definitely do like that Cybex official Google Cloud Certified Professional Cloud Architect certification book. Very much so. And right after we do the next video, we will Leo will be demonstrating how to create a budget, for example, and how to set up your account. So make sure you stick around. Give me a hashtag Google Professional Cloud Architect or something like that so that I know you're here in the chat box. Maybe if you're having a good time, give it a like, subscribe to the video, hit the bell to be notified of new stuff for your architecture career. And Chris, let's go back to the content. Continuing our high-level overview of the Google Cloud and its services, we're going to get into logging. So we have to be able to run our systems, and logging is going to be a critical component of it. So Google has a logging component called cloud logging. And in many cases, the Google convention is stick the word cloud in front of something. So that may help you on an exam. So cloud logging is going to be a real-time log management and log analysis tool. And it enables people that are using the Google Cloud to store, search, analyze, monitor, and even alert based upon logs. We can, with cloud logging, ingest custom logs from any kind of source that we might ever want. And it's a fully managed service, so there's going to be nothing to manage things like servers, etc. And we can integrate cloud monitoring with other services. So it's going to help us get a lot of information, which we could then use to see what's going on with our systems, track the health of our systems. Now, in AWS, you have something very similar called CloudWatch logs. And quite frankly, in any data center, we've had logging for the last 50 years or so. But cloud logging is going to be very similar to CloudWatch logs. Now, we're also going to have this concept of cloud monitoring, and that's a full stack, fully managed monitoring solution. So it gives us the ability to get visibility into performance, uptime, and the health of our applications, and get custom metrics and business alerts. So that's going to sound a lot like AWS CloudWatch monitoring to you, because it is, and all these solutions are going to sound very similar. Now, we have the concept of cloud trays. So when we're working in the cloud, we've got these distributed applications that are everywhere. And when things don't perform well in a distributed environment, it becomes very hard to actually see what's the actual cause of the problem. And that's where we're really coming up with this concept of cloud trace. And it's going to be a distinguished distributed tracing service. So it's going to give us the health. So we're going to be able to look into our environment and collect latency data from our application, track requests from various parts of the application through the journey. We'll be able to get some in-depth latency reports, and with that, we'll be able to identify some performance issues. And we can work across virtual machines, containers, and other types of projects. So if you really look at what's going on with CloudTrace, it's enabling you to look in your environment to see performance problems. Kind of like a medical professional would use an X-ray. And actually, Amazon named their version of this service AWS X-ray. And it's about the ability to really look in and see what's wrong, seeing how to solve problems. Now, the Google Cloud is one of the most developer-friendly things you could possibly imagine, and they enable you to interact with the Google Cloud very easily. Obviously, there's a management type console, there's a command line interface you can use, but you can also connect via the software development kit. And you can do some of these things via the command line this way as well, but you can also use code. And the point is here is you can, in whether it's Java, Python, Node.js, Ruby, Go, .NET, PHP, you can use one of these languages. The developers can use one of these languages to interact with the Google Cloud environment. And this enables much more simplified management and things along the way. So that's one of the things that are typically going to be pretty great that we're actually dealing with here is the ability to be able to go in there and really be able to see what's going on and be able to interact with the cloud in a much easier manner, because we don't want to be interacting with it via the clicking boxes on a management console. It's just not going to be efficient. So let's talk about some more developer tools in Google, where we're going to have cloud source repositories. And what is that? Where do you store your code in these things? It's going to be a private Git repository service. So cloud source repositories, think private Git. And you can use this to develop and design and securely manage your code. You can store it in Git. You can extend the Git workflow by connecting to various tools like publisher subscriber messaging, cloud monitoring, and cloud logging. We can mirror code from, say, GitHub or Bitbucket. And we've got some fairly powerful code search, browsing, and diagnostic tools that is actually coming with these cloud source repositories because it's Git. And we can, of course, use regular expressions to search across directories and do any of the things we could in a normal Git type environment. So it explains to you what it actually is. Now, at some point, we may need to keep track of all the containers we have. So, of course, you need some form of container registry service. And what we're dealing with is it's basically a private Docker repository, which is going to enable you to store, manage, and secure your container images. You may want to perform vulnerability analysis on your container images. You may want to manage access control to see who can even access various container images. And you may want to integrate your container management with your CI/CD pipeline for automated Docker pipelines. And in order to do that, you're going to need some form of registry that kind of keeps track of all this thing. So that's what we're talking about with container registry. Now, there's a concept of JFrog, Artifactory, and Amazon has the Elastic Compute Registry. Or the Elastic Container Registry. That's what we're really talking about, just a registry of your containers. So there's other environments and things we want to talk about as well. I want to really talk about Google Anthos a little bit. And Google Anthos is a managed platform that's going to help organizations really manage their applications across the reality of today's world, which is hybrid and multi-cloud environments. So Anthos streamlines deployment. It helps with management and operation of containerized applications because it's using Kubernetes service mesh, which works across all clouds. And it's designed to meet hybrid and multi-cloud platform as a service requirements. It gets you out of that vendor lock-in by using any kind of proprietary anything. And it enables running, managing, and even governing applications across multiple clouds and hybrid clouds. So that's typically we're talking about Anthos. So there's a couple things we'll talk about Anthos and its key components. We have the Anthos Google Kubernetes environment. And what that does is it's going to be an enterprise-grade container orchestration and management platform because it's Kubernetes. And it's going to support the deployment in both cloud and on-premise because it's Kubernetes. So we have the concept of Anthos configuration management, and that's going to govern configuration policies across different environments. So you can determine how you want things configured and you can enforce it. We also have this concept of this Anthos service mesh, and it's powered by Isoflow, and it's not actually made by Google, and it provides a service mesh architecture. It makes networking fairly easy and the routing of your traffic back and forth. It uses mutual tunnel transport layer security. So you can think of it as MTLS in order to secure this service mesh and the end user component. So we're going to have that layer of encryption, and it's going to be done, it's TLS encryption, and it's going to simplify any kind of role-based or fine-grained access controls. And of course, with Anthos, we can define some security controls across our environments as well. So it gives us the ability to control a lot of things in a multi-cloud or a hybrid multi-cloud environment, which is the reality for today's compute world, especially cloud computing world. Now, how do we get our data to the Google Cloud? Well, obviously, if we've got a wire or a private line or a direct interconnect, we've got a wire to push it on. If we have an IPsec tunnel and we have enough time, we can push it over the IPsec tunnel or the VPN to the cloud provider. But what if we don't have the biggest network bandwidth to the cloud provider, or what if the connections we have are fully used? We still have to get our data to the cloud provider, and here's where we get into the storage transfer service. And what it really is it makes it easy for you to take your data from the data center and transport it over your wide area network to the cloud provider. So if you've got a lot of data to move, there's lots of ways to do it, and this can be done fairly easily with the storage transfer service. Basically, what's happening is that you're going to use your network, you're going to connect to the Google network, and it's going to help you transfer your data. You could deal with petabyte scale data transfers here. And, this is one of the ways we can use the wide area network to get our data from point A to point B, assuming we've got a good network and we've got good bandwidth. If we don't have it, it's not going to work, and we're going to have to do something different, like use a transfer appliance, which we'll talk about shortly. But this is the ability to synchronize your data in two places over your wide area network. AWS has a similar service called DataSync. So if you've got the network bandwidth and you've got the time, you can just simply send your data over to the cloud, over the network. But what if you don't have a lot of time? What if you've got to move things quickly, or you don't have a big network connection? Well, this brings us into the world where how do you get your data to the cloud? Well, you take your data, you copy it onto a device, and basically the device gets shipped to Google Cloud, and the Google employees put it back in your environment. So we have this concept of a transfer appliance. It's going to sound a lot like the AWS Snowball, because it is. And basically what it is going to be a ruggedized computer and a whole bunch of hard drives with high-speed networking. And what you're going to do is you're going to send your data to this device and ship it back to Google. So very similar to, again, AWS Snowball. Now, the next thing we're going to talk about is the cloud asset inventory. So you need to know what systems you have. And hopefully you've got a great set of architectural documents, and you've got a really strong architectural repository. You understand what you have as-built drawings, you've got documentation that explains everything. But in many cases, organizations don't. And Google has this cloud asset inventory, and what it does is it audits metadata about your stuff. So it will view, monitor, and analyze all of your resources and policies. It will give you the entire inventory of what you have. It'll give you changes and give you real-time notifications for things that are changing in your environment. And it can help sift through your IAM policies. Remember, IAM is determining who you are, what you're allowed to do, and keeping track of it, and making sure you don't have to do things that you're not supposed to. So we get a lot of information out of the Cloud Asset Inventory. It's pulling the metadata of various services that you have. So it's going to feel very similar to AWS Config. And it's going to give you information about what you have, and then make it easier for you to do things. So let's talk about the Security Command Center. And Google has its Security Command Center, and basically that's going to be a security management platform and a data risk reduction platform. And what it's going to do is it's going to give you some straightforward views and inventories of your cloud security vulnerabilities, any kind of threats or compliance issues that it sees. Now, remember, this is an automated tool, so what it sees may or may not be correct, but it's going to give you good information nonetheless, and then you can verify that information as valid or non-valid. So it includes a suite of tools and capabilities that are only going to be available in the premium version. It will give you some security health analytics, which will really scan for security misconfigurations and compliance violations. It will give you some event threat detection, so it's going to use Google's threat intelligence engine for log-based threat detection. So it's going to look at logs much like, and determine if it sees a problem. It's going to do some web security scans that can identify some common web-based vulnerabilities on publicly facing, well, let's say endpoints, if you will. And it can kind of give you some information on what it finds. And, this kind of information, all this information from the security center that it's giving us is pretty valuable because we've got some information about configurations or misconfigurations or compliance violations, which may or may not be right, but at least it gives us something to look for. It gives us information for things that it thinks may be a problem, and it's scanning things. So good tool here. Now, companies may have their own tools that they choose to use, but this is a Google version of a tool. But the point is now you're collecting lots of information. You can send it to your SIEM systems, your security event monitoring systems, and they can be monitoring these logs, other logs, and all of a sudden it notices an event occurs, and they can correlate that event for you. So lots of great things that come out of this. Now, when it comes to identity and access management in any kind of security, it's really about, is the right user using the system? Who are they? Which we have to authenticate them. We have to authorize them. Okay, Mike can access this, but Mike can't access this. And then we have to track or log what we've done for accounting or auditing. And this brings us into cloud audit logs. And what it is an activity visibility service. It's going to tell you who's using the Google Cloud, the kind of things they did, any administrative actions like launch a machine, delete something, that kind of thing. And it's going to be immutable, always on trail. So you're always going to know what's happened. And this way, someone can't delete something and say, I didn't do it. And this is going to be great for incident management. It's going to be a critical part of auditing our accounts and auditing our systems, which is a critical component of security. And this is the Google Cloud auditing log. So it's called it's called Cloud Audit Logs. Now, if you're familiar with AWS, you may have heard of AWS CloudTrail. Same kind of thing. These things have been around for decades because IAM's been around for decades too. So now we have our environment. We've talked about some more environments. Now you'll recall that a VPC is basically your virtual private data center. And in a data center, you want a security perimeter, right? So what we have here is we have these VPC service controls, and they can help you create a security perimeter. And it will constrain some of your things like cloud storage, cloud bigtable, BigQuery, and it keeps your data from leaving your VPC. So it's going to ensure that data is not exfiltrated in case you maybe had a misconfigured access control. So it's going to enhance your security, and it's going to provide some data loss protection to make sure critical data doesn't leave your system. Now let's talk about data loss prevention. Again, there's going to be industrial tools we can use across all our cloud providers, but Google has some data loss prevention tools. And the Google data loss prevention tool is called the Cloud Data Loss Prevention. And it's going to be a managed data protection service. And it's going to feature a lot of things that will discover and classify and even protect sensitive data. It can support de-authentication messages for streaming and stored data. It can constantly scan the environment for things that don't meet the classification requirements. So it's a good data loss prevention tool. Now, if you're in 3 clouds, it's going to be hard to deal with 3 different data loss prevention tools. You may need one tool that you put on all clouds. But if we were just in the Google Cloud, and again, this is a Google certification, they have to tell you, and you have to get certified on knowing what their tools are. Whether you use them or not is going to be another service. Now, anytime we're dealing with security and privacy, at some point along the line, we need encryption. And part of encryption is to basically have an encryption key and a decryption key, so to speak, and that way, and to be able to understand the message. So if I've got a message that's encrypted and you need the secret decoder key in order to be able to decrypt that message, if you don't have it, you can't access it, which is great. But you're also going to need a key management service to make sure that the right people have the keys and nobody else has the keys. Keep track of the keys, rotate the keys, and store the keys in a secure management. So there are lots of great cryptographic key management systems that exist out there. And the reality is in multi-clouds, you're probably going to need a more industrial system. But Google has a very good cloud key management system. It is an excellent key management system. And it enables you to manage your keys. It'll manage the encryption keys for sensitive data. It'll support customer-managed encryption keys for customer-supplied encryption keys. It integrates with the cloud hardware security module for FIPS 140-2 level 3 device protection. So good, strong encryption. Now, sometimes we need a hardware encryption tools as well. So this brings us into the cloud HSM. And this is going to be a managed hardware security module. And the reason we're going to use this or might use a hardware device is it will protect our cryptographic keys, and it will keep them in a FIPS 140-2 level 3 certified hardware security module. So it's going to be good security this provides. And being able to keep your keys private and store them is going to be absolutely critical to ensure compliance for things like financial services and healthcare. And the cloud HSM can integrate into the cloud key management system. And you're going to pay as you use it, pay as you go. Again, this is a great tool. Now, in multi-cloud, we might use a more industrial tool, but again, this is a good tool, and it's going to be part of the exam. So how might you interact with the Google Cloud? Well, there's going to be a couple of ways you can do it. You can use the Google Cloud Console, which is basically a web-based interface where you can click a few boxes and it gets it done. So that's going to be one way that you can actually do it. Now, of course, you can SSH to various tools if they're accessible to your private network over the internet based upon how it's set up. So you'll be able to deal with certain things as well. But, you can use the web browser-based console. You can also use the command line. And the command line will make it very easy by comparison for you to get things done, assuming you know and understand the command line. So kind of keep this up. Now, Google Cloud has got a couple of different command lines. They've got the G Cloud command line, which is the primary tool for creating and managing resources. They have a BQ, which is a big query command line if you were going to be using the proprietary database. We have the CBL, which is the Cloud Big Table command line if you're going to use the Google NoSQL database. And we have GS Util, which is the Google Cloud Storage command line tool. And of course, we've got the Cube CLI, and that's going to be the Kubernetes command line tool. So you can click a lot of boxes on a website, which is going to take forever, or your cloud engineers can use a command line, which is going to make it very easy. Now, of course, we can also push things over APIs and client libraries as well. And we can push things through Google Cloud APIs as well. We can connect to application APIs to provide services and various things. And of course, there's going to be administrative APIs. So when we talk about APIs, these are going to be programming interfaces to be able to access one system to another system. And there'll be a lot of that in Google Cloud as well as other things. So these are typically speaking what we're really dealing with when intro to Google Cloud. Now, we're going to be discussing cloud architecture, and this is a cloud architecture exam, and there's a little bit of architecture in the Google Cloud. If you want to learn a lot more about what does a cloud architect do and the skills of the cloud architect, join us for a free webinar. We run one every single week on how to become an architect and all the skills you need. The link is going to be in the description of this video. But in this overview section, we're going to be talking about some cloud architect skills, and The key here, as an architect, your job is to drive business transformation for your client. What does that mean? We're here to make our client's business better. That's the whole point of the architect, is to enhance that business's efficiency. And what could that mean? It could be a hospital where a greater percentage of the patients leave the hospital without having a negative effect in the hospital, like an infection. It could be there. It could be an online retailer where we're trying to increase sales. It could be, how do we improve the employee productivity of a business? It could be any of these things. So the first thing that we typically need to do as architects is understand our client's goals. We typically need to understand the client's business processes or their business architecture. I've got videos on the YouTube channel on what is business architecture and how that and what that is, for example. Then we need to understand and baseline our client's current technology across all clouds to be able to see if it'll meet their future business goals. And if not, then we're going to need to create an architecture team to design the architectural strategy or the blueprint to get that client to their goals. Now, at some point, we're going to have to take that architecture, show it to various stakeholders across the organization, get their feedback, and redesign that architecture based on stakeholder feedback. We'll have to represent that architecture back to the client, get any feedback, tune the architecture several times in most architectures. At some point, we'll create a statement of work. We'll respond to any of RFIs, RFPs, RFQs, create a governance structure for the architecture, create a change management structure, and typically we architects go to a new one. So there's going to be a lot of skills related to business acumen, leadership, executive presence, emotional intelligence, executive communication skills, CXO, relevancy, sales skills that are going to be critical for the architect. And none of them are going to be covered in this course. But this is because it's a certification course, not what we do. And that's what we do in our 1,000-hour type training. But I want you to at least think about the skills you need, because they may ask about some of these skills on the architecture exam. So you have to be able to understand the client's business objectives. Business objectives are not just some tech thing. Business objectives are business goals, whatever they may be. And you as the cloud architect to be able to translate those business objectives and figure out what kind of technology solutions will get that business to its goal. So you're really aligning an organization's people, processes, and technology. Now, the architect has to be a trusted advisor. And what does that mean? It means you can't walk into a client and say, I'm excited about the Google stuff and I got all this beautiful Google stuff for you. If you do, you're an enthusiast and you are the most dangerous person in the world. And here's the reason. Imagine a doctor that only liked to prescribe Pfizer drugs. And every time they walked in a room, they prescribed Pfizer this, Pfizer that, Pfizer that. Now, Pfizer makes some great medications, but they don't make the entire pharmaceutical library of the entire world. And we need our doctors not to be biased by any pharmaceutical companies. And we need our architects to be biased on making our customers successful and not fall in love with any type of technology or any type of provider. So as architects, we have to be a trusted advisor. As strategists, we're really strategy consultants. Now, we have to convert the client's needs into a solution. And that solution will involve people, processes, technology. We'll have to build training plans as we design the architecture to get the customer to adopt it, and so much more. Now, the key is business, business, business. So if we walk into a client to enhance their business and you don't know business, you're not going to be able to do anything about it. So, we train business on our clients. If not, you can get a master's in business administration and learn business, but you have to be able to understand an organization, understand business processes, understand business architecture, understand the business inputs and outputs, and understand the forces of business and how you can optimize them with and without technology. So that's going to be so important that you have to understand business skill, understand business. You're also going to have some extraordinarily good communication and collaboration skills, because in most cases, an architecture will take 6 to 12 months to design and take a team of 15 to 50 people. So we have to figure out what the organization is trying to achieve. Are they trying to increase sales? Are they trying to reduce patient deaths that are in a hospital? Are they trying to improve the customer experience? What is the actual goal? That is the most important. Now, let's talk about cloud migrations. Initially, we thought it was going to reduce client expenses. And part of your exam is it will make costs cheaper. In reality, it won't. And it's not going to make it cheaper, but that doesn't mean it's not worth it. Cloud computing is very agile. In the data center, I need to launch 100,000 servers. I've got to go buy them, rack them, stack them, put hypervisors on them, and do anything I want. I need 100,000 servers in the cloud. I can use a DevOps engineer can use AI to create an infrastructure as code script, tune it, and then launch those 100,000 servers potentially in an hour or less. So from the time they decided to the time I started, assuming it's something very simple, and it's not going to be that simple, but it gives you the point. It's so agile. Now, one thing we have to definitely talk about is when we move to the cloud, we take what's usually considered a capital expense and it turns into an operational expense. So I'll explain to you what is a capital expense. A capital expense is something you purchase. An operational expense is something you have every single day or week or month or when the business is running. So you have an operational expense. Let's take it to your house and most people. If you bought a house, that was a capital expense. You bought that house and you didn't have to pay for it day one. You financed it. Now, you may have rented a property in your life, and that's going to be a capital expense. So it is what it is. Now, is a capital expense better than an operational expense? Sometimes, based on the organization's capital structure. Is an operational expense better than an organization's capital expense? Sometimes based upon the organization's structure. So it's going to be based on debt and interest rates and financing and taxable situations. So don't just assume moving to the cloud, going from CapEx to OpEx is a good thing. It could be the worst thing in the world, or it could be the greatest thing in the world, but you need to know. But understand that there's different tax implications of CapEx and OpEx. For example, capital expenditures are typically depreciated, where operational expenses are typically written off, and all that needs to come into a tax. So understand that there's a shift in the way organizations actually pay for things and how it'll affect their balance sheet. Now, with the cloud, we have to understand it's going to be very expensive ongoing to maintain it. But we're not usually buying something, so it may or may not make sense. It may make sense to buy a server for $300,000 versus paying $5 million to run on the cloud for a few years. And people would say, but what if we don't have the $300,000? You don't have to. You can finance that $300,000 and at approximately 7 or 8% interest. It's about $90,000 a year. And it might be cheaper, $90,000 a year, than to finance it, than it might be to pay $1.5 million a year to rent it on the cloud, based upon the organization's business. So understand it's a shift from capital expenditures to operational expenditures. Not a good thing, not a bad thing. It's going to be based on that business, whether it's good or bad. So you're going to the cloud architect, the enterprise architect is always going to have to be able to communicate to the chief financial officer and explain the total cost of ownership and build a business case that's going to show some return on investment capital for that business. If you can't do it, for the most part, you're not going to be selling your solutions to the client. Now, when we get to the cloud, typically speaking, we're trying to do a lot of things. We're trying to enhance security. And cloud computing is not more secure than the data center, but many people have the data centers that are not secure enough. And all in all, a well-designed, properly architected data center would be more secure than the cloud environment because of tougher perimeters. Having said that, in many cases, the cloud computing provides a better security environment than the data center because organizations don't have the sophistication to build very good data centers and very secure data centers. You want to deal with a big bank? They have the sophistication. You want to deal with a global internet service provider? They have the sophistication, but not everybody does. One of the goals that we're trying to achieve, typically speaking, is data reliability. Look, data is an asset, and enterprise architecture usually considers data to be an asset. But what do we do with that data? How do we protect that data? How do we make sure the data is good data, accurate data? So we're typically in any kind of migration or any kind of enterprise architecture, we're typically thinking about this. We also have to think about downtime. Downtime has a very unique cost to a business. There are businesses that if they're down for an hour could go bankrupt. There are other businesses that if they're down for an hour, it doesn't matter. There are some businesses, if they're down for 10 minutes, somebody can die. And there are other businesses that can be down for 10 minutes and nothing happens. So we have to understand downtime and minimize it to the level that makes sense for the business and its actual business needs. I've worked with clients that lose $1 million a minute if their systems are down. Now imagine what a 4-hour outage would cost them. $60 million an hour, 4 hours would be $240 million. That might be terrible. It might be worth adding some additional redundancy and pay for it to not have that. You're going to have a lot more redundancy. Now, in any good architecture, and we can do this on Google Cloud, we can do it in any environment, we're trying to reduce the disruptions of services and make sure systems are available when needed and work properly when needed. So that's going to be a big goal here. Now, in any good architecture, it's only going to be as good as the information we receive from the client. One of the biggest things we do as architects is work across business units and communicate with various stakeholders. If we've got an enterprise that has 10 different business units, we need to make sure that the systems we put in place and for one business unit, do not harm another business unit. Do they need separate systems? Can they use the same system? So we're going to have to get the stakeholders involved. We're going to have to get their information to make sure we design the systems properly in a manner that's going to enhance business performance. We're going to need their insight and feedback into the architecture, and we're going to have to get their support. Because when it comes down to rolling out an architecture and getting people to use it, if we don't have the stakeholders buy-in, we will get nowhere. So we're going to have to get stakeholder engagement, and this is going to be critical as part of our business requirements and our architectural solution. We're going to also have to be able to create a return on investment capital model to be able to show the customer that we have some positive gains from the money we're spending on there, as well as figure out the actual total cost of ownership versus what people think it's going to cost to be in the cloud. So these are some of the things we need to think about. As I mentioned, in the data center, we buy the stuff, and it's capital expense. But what if in the data center, instead of buying the stuff, we decided to lease the stuff or rent the stuff? Well, now our data center is going to be an operational expense versus a capital expense. So on the exam where they say a data center is all capital expense and cloud is mostly operational, that's partially true, but it depends on how the data structures, the data center is set up and structured and how the equipment comes. Traditionally, though, you have to build a data center. You have to build a big facility. You've got to bring in a lot of power, which gets very expensive. You've got to bring in backup power and generators, which gets expensive. You've got to bring in a lot of HVAC, and that gets very expensive. Then you've got to buy the equipment, buy the racks, buy everything needed, and set it up, rack it, and have the staff to maintain it. So typically speaking, with a data center, there's a lot of things to purchase up front. But you pay a whole heck of a lot, yes, to use them when you purchase them up front because you own them. Now, when we go to the cloud computing, we only pay for what we use, which may or may not be good. We actually pay for what we provision. So we don't have to buy something, but we pay a lot more for it. For example, a server that might cost $300,000 may cost $4 or $5 million over several years to run it on the cloud. We didn't spend the $300, we paid a few million. Is that good? Is it not good? It all depends on that business. Did they benefit from the speed and the agility to go to the cloud instantly? Did that give them a first market mover advantage that assisted their business? Or did they just pay so much and hurt their business by using the cloud? That's why the architect needs to have so much business acumen and financial knowledge. So one thing I can tell you is when we go to the cloud, for the purposes of your exam, it's cost efficient. For the purposes of reality, it's probably not. But you've got to pass the exam. Cloud computing is agile, and that's worth a lot, and you're going to pay a premium for it. We typically can always want to look to optimize on the cloud our operational expenditures. So, we're constantly looking, are we using the right size? If not, can we change the size? Is this application running cheaper on the cloud? If not, let's move it back to the data center. So it's about optimization of capital expenditures and operational expenditures to get the clients to their goal. Now, we have to be able to address total cost of ownership, and I'll explain what that is. So if I buy a server for $300,000, maybe I need to pay $5,000 of electric for that one server over the next 4 years. Maybe I need a tenth of a full-time person to manage that server for 5 years, and maybe that cost me an additional $150,000. And maybe I need some insurances. So I might be dealing with a server that might cost me $400,000 as a total cost of ownership, but it might still be cheaper than the $5 million on the cloud. But we can't basically just look at one thing. We have to know the total. And we're on the cloud. We can't just think of just the server. We have to think of the storage. We have to think about data transfer fees. We have to think about all the stuff that we're going to be paying for along with that server, which could become much more expensive. So whenever we're dealing with the chief financial officer, we're going to have to prove both that this is a good use of their money to go to the cloud, and two, that we're actually making a difference with the environment. And we can't do that if we don't know our total cost of ownership. Now, we will typically dealing with service level agreements whenever we're dealing with a third party. And a service level agreement basically is the provider offers to give you a level of service, and if they don't, they reimburse you a certain amount of the money you spent. So that's typically what we're talking about with an SLA. Now, I'll go over SLIs, SLAs, and SLOs. But an SLI is what you call a service level indicator. And it's going to be a quantitative measure that's going to give you the chosen characteristics of the level of service. And what does that mean? It means the service should be able to be 99.99% available, otherwise known as 4 nines. And it's going to measure availability rates, error rates, response times, etc. Now, we might be dealing with a service level objective, or SLO, and that's going to be a specific numerical target that's going to explain the expected level of service. So if you're dealing with the cloud and you expect 5 nines and you design your system across, theoretically, and it probably wouldn't do this in a single cloud, but two zones in 2 different regions, theoretically something like that could get you to 5 nines, assuming you have the absolute right level of change control procedures and redundancy and other things. You could. Of course, I don't think you're going to get 5 nines on any single provider, but that's why you typically would go multi-cloud for this. But keep that in the back of your mind. That's what a service level objective is. The performance goals. Now, the service level agreement is going to be the guarantee that the cloud provider is going to have its services available when you need it. So if Google Cloud Storage is supposed to be 99.95%, that's its target, and it's not, they might give you some financial credits. So it's giving you a little bit of your money back should the provider not meet their expectations. Now, that doesn't mean it's necessarily going to compensate you for the real challenge. Imagine you have an emergency services system that's cloud-based, and the cloud is down for 30 minutes, breaching your 99.999 guarantees. Well, what if somebody dies in that 30 minutes that the cloud's down? Well, sure, you'll get a little money back, but that's not going to cover the person that died. Or a hospital where systems were down and somebody died, and 2 things. So that's why we can't just look at SLAs and view it as a pure guarantee, because we have to look deeper and we have to protect ourselves. Because while SLAs are well-meaning, getting some money back if somebody were to die because of an outage is not going to be sufficient or acceptable. Or having a bank that loses $100 million in an outage that gets a credit of $500,000 in a service level agreement is not going to cut it. So at least you understand what SLIs, SLOs, and SLAs are, and their strengths and weaknesses and limitations. So we need to think about that. So when we start thinking about the technical piece, we have to define the what of the system. What is the system supposed to do? Are we extracting data from one thing to another? Are we providing an AI recommendation engine to get a person to spend more money? Are we using AI to mine data to determine when we would buy a fuel option contract for an airline to cut their fuel costs? So we have to define what the system is going to be. Now, we also have to define some non-functional things, how the system should perform, how it should handle some constraints. And that's something we're going to need to describe along the way. And we have to understand the difference between a technical need and a business need. Now, understand the Google Professional Cloud Architect, like all certification exams, like the AWS Solutions Architect Professional, the Azure Solutions Architect Expert, cover none of the business part of the architect role, which is 80% of the role. They only cover the technical piece. So keep that in the back of your mind. That's why we train people the way we do in our architect programs. If not, go get an MBA and learn some of these skills elsewhere, because you're going to need them for a great architecture role. Now, when you actually take the exam, and this is a high-level overview, we're going to get into the meat of the content, understand that a lot of the situations will be scenario-based. And you're going to be dealing with scenarios, and you're going to be thinking about the things that will help solve them, which is quite good. So we'll be thinking about things in study-based questions. It could be about scaling strategies, for example. It could be about which technology to use. So these are going to be the kind of things that you're going to see. And when we actually get to that, when you actually get to the exam, but this is an overview of the Google Cloud and its services. Now we're going to get a lot deeper into the Google Cloud now that we've introduced these concepts to you.
Welcome back, everyone. So what we're going to do is I'm going to answer some questions for a few minutes, and then Leo and Chris will explain the format of the labs, some of the labs that are going on, that kind of thing. But I know there was at least one question on there. I saw a cool, fun question pop in on Anycast and Multicast. So even though it's not necessarily part of this concept, I really wanted to answer Ngozie's question there. So can I talk more about Multicast and Anycast? So yeah, so they're two completely different things. Anycast is where we have two devices that use the same IP address for high availability purposes, and I'll show you. Multicast is when we send something to several people at the same time. So they're very different, but we can go through this fairly quickly. Let me just show you. I actually, while I saw the question came in, I started doing some whiteboarding. So let's talk about Anycast in action. In Anycast, what we have here is a situation. Let's say this cloud here is the internet, and 8.8.8 are Google servers. So what we have is we have these two servers that are synchronized here in Anycast, and they have the same information on them. And here's the reason why. Here I'm over in Florida. I want to go to this website that's got cat. So I go to the cat website, whatever it is. I enter that in my browser, and it goes to my local DNS servers, which is 8.8.8.8, which is a Google Anycast address. The server responds to me, and then my browser gets redirected to the website with the cats, and I'm all kinds of happy. Now, the thing with Anycast is it's designed for high availability. So here I am in Florida. For some reason, the local server just crashes and it goes away. It's no longer with us. And the way Anycast will work is I want to go to the cat website. I enter the information. It redirects me to this other Anycast webpage. The other Anycast webpage responds, and then I get redirected to the website that I want to go. So that's Anycast. Now, by comparison, Multicast is a little bit different. Multicast is I send something to the receivers that want to receive it. So let's say I've got a TV channel and I want to receive that TV channel. What I have to do is I have to receive it. And the process of Multicast is going to be something like this. We have the host, and the host sends, I want to join this channel 224.6.8.9. And that is an IGMP join group message that typically occurs. That switch will actually look at that IGMP message and say, add that port so this person can receive it. Now the router will see that request and say, whoa, who has the source address to the IP address of 224.0.8.9? I don't know. Send a request to join, *G join up as a particular to the rendezvous point. The rendezvous point will say, I have the source to this, and it will add the source to its outgoing interface. This will be added to the outgoing interface, and then this host can receive it. Now, all of a sudden, we've got another host over here wants to receive it. All they have to do is do an IGMP join group 224.6.8.9, and now that person's receiving it. So basically, we now have two users here that are receiving the same stream while no one else wants to receive it. Whoops, no, let me go back and change so no one else wants to receive it. Now, all of a sudden, I've got a member over here that wants to do it. They send an IGMP join group and they get added. So realistically speaking, that's what's going with Multicast is more than one people can say it. Now, you see this rendezvous point, which is the authoritative source of information of where this lives. What you might see is you might see two rendezvous points over here, and both of them may actually have the same IP address, which is in an Anycast environment that you may see. And that way, if one of the rendezvous points goes down, just like DNS in our previous example, we're good because they both have the same IP address. So realistically speaking, that's the difference between Anycast. Anycast is more than one thing with the same address for high availability. Multicast is I send something to the people that want to receive it, and I only have to send it once. The network replicates it. Really, really great question. So if there's another question, I'll answer it. Otherwise, and realistically speaking, let's get Leo, let's get Chris. They can talk about the two new labs that we're going to do for the day. And hopefully that'll be fun for others. There is also a video on our YouTube channel, What is Anycast DNS, that I made for you. And maybe one day I will do a Multicast workshop because I spent a long time as a principal solutions architect as a Multicast consultant. So it's kind of fun, geeky stuff for me. So if you guys want Multicast, we can do Multicast. Welcome, Chris. Welcome. Chris is our chief operating officer. He's back there making sure things actually work. And all the stuff is supposed to flow and the content flows, and Lee and Leo don't forget to show up. And that's Leo who actually did all the official tech demonstrations.
All right. So I just wanted to do some housekeeping notes as it relates to the labs that we're going to be going through. So, of course, this is a live YouTube live stream. Interaction between the two of us is a bit complicated between us and you. So what we're going to be doing is we're going to be playing these lab demonstrations for you, and two ways that you should approach these. Of course, watch them in real time with us, but also watch them again on the recording. The recordings are going to be available on YouTube as soon as YouTube finishes the stream. The reason I say that is because we all know following things along and doing it yourself, and then coming back and doing it and going back and forth between, oh, what did they do there? Okay, let me rewind and let me make sure I do exactly what they did over here, and I understand what's going on there. So there's going to be two different approaches for you to take. Watch it with us in real time. Some of them, I would venture most of them probably not able to actually be done alongside with us in real time. Some of them can be. I'm just speaking from my experience. If I'm doing a lab for the first time, I'm probably going to stumble and bumble, and this 30-minute demonstration is going to turn into a 5-hour thing for me because that's learning. So that's why I wanted to emphasize that there's not just one way to watch it. It's not just watching these live with us and that's it. It's watching them and then watching the recording again, pausing, rewinding, fast forwarding once you figure out that thing that you couldn't figure out 15 times in a row. So I just wanted to say that the labs that we're going to be doing today are kind of like laying the ground. We're going to be doing creating your account. We're going to do a setting up multi-factor authentication and creating a budget. Basically, just getting you started. So you're going to be creating your Google Cloud account. You're going to set up your multi-factor authentication, make sure you're safe, and then you're going to set your budget so you don't go overboard. If you want to go along with us. So I just want to set that groundwork. We're going to play these 3 demonstrations. We're going to take a quick break between each one. Not so much for questions, just to give people a little breathing room between them. And then I want to let us do some questions after we do those 3 videos. Now, that's not how we're going to do them all throughout the boot camp, just this particular set of getting you started. But I just wanted to share that again from the housekeeping and operations standpoint of running the stream. Leo or Mike, do either of you want to share anything before we play them the demonstration for creating an account?
Leo? Okay.
Oh, there you go. You're unmuted now, Leo.
Well, basically, you introduced that, Chris. These are the labs to anyone that will start touching the tech, right? Touching the cloud provider. So how to create an account, how to make that account a little bit more secure than only using password, and how to keep track of the costs, even if Google offers a free tier, some free credits, but it's a good idea to keep track of the costs.
Yeah. And actually, you know what as a reminder, we also have for AWS, the solutions architect, the Azure solutions architect expert, and there's labs that you can do with those if you want to play with some other clouds as well. Mm-hmm. And if you didn't know, we have a CCSK, we have a CCSP, we even have a CISM security thing that you can get on this channel. So if you have anything you're curious about, please feel free to dive deeper.
All right. So to keep Mike from going down too many rabbit holes about what we offer, let me start the video for how to create your account.
Hello and welcome to this lab. In this first lab, I will demonstrate how you can create your Google Cloud Platform account. If you already have a Gmail address, you can click sign in and enter the email address and password. If not, you will need first to create a Gmail address and then use those credentials to sign in here to this site, cloud.google.com. I already have another tab with my email logged in, my Gmail logged in, and I see here Get Started for free. I click this button and I am presented the step 1 of 2, account information, and this shows the email address I'm using, and then it shows the country I'm currently located, and here on the right you see some description of this offer, which includes $300 US dollars in free credit to spend over the next 90 days. And there is no automatic charges according to this offer. You only start paying if you decide to activate a full account, pay-as-you-go account, or if you choose to prepay. So if you don't choose to activate any of those options, you can spend $300 US dollars over the period of the 90 days. I will click Agree and Continue. And it will ask in the step 2 of 2 to create a new payment profile. This will only be used after the 90 days period, or if you decide to activate a full account, a pay-as-you-go account, or a prepay, if you choose to prepay. So I will click the plus sign here and enter the required information. The profile type you can select as individual if you are creating your own Google account to practice the labs and to learn about the Google Cloud Platform. The other option is to use organization, but this is not a cloud architect or a cloud engineer, a system admin that will create this account for an organization. So choose individual, as I believe you are creating this personal Google Cloud account for learning purposes, and you need to enter some personal identification. Click Verified. And then you need to enter more information about your address. Finally, choose the city you live in, and then click the Create button. Now the payment profile is done. What you need to add is a payment method. Click the plus sign to add a debit or credit card. And then you need to enter the information for the payment method.
Kita tidak family story.
Yeah.
Once you enter the information, click Safeguard. then you can click Start Free. Now it asks for some information. Select some of the options and click Next. And finally select the role. I will choose Other and add Student. And click Done. So welcome. And here I have spent 0 out of 1,981 credits in Brazilian reais, which is equivalent to $300. And this credit will expire on June 25th, 2025. This is it for creating the account. See you in the next lab.
All right, welcome back. So that's how we create an account.
Exactly. So as we go through and Leo does some demonstrations, if you've got a question, drop it in the chat box. If you're watching it after the video, maybe put it in the comment section. We really want to do what we can to assist you.
Absolutely. Leo, you want to add anything you want to add to that? I think it was pretty clear from my perspective.
Pretty straightforward, and the offer is valid. I don't know if they have this only from time to time, but the offer is valid, currently valid.
All right. And I see that Sri asked about slides being available in the course. So we don't actually have any slides, but what we do have is we've got a study guide that goes along with this. I'm going to put the link to it in the chat box there for the study guide. That'll be much more in depth than any slide would have been. But these demonstrations will be available on the recording, of course. So more than welcome to watch that recording, rewind, pause, fast forward as many times as you want to. And like Mike said, if you're watching the recording later on and you've got questions, just put them in the comments, and we watch our comments like hawks. So
yes,
we'll keep an eye out for those. Without further ado, let's move on to the multi-factor authentication, and then the really fun one of creating a budget. I like budgets. So here we go.
In this lab, I will demonstrate how to make your account more secure by setting up a second-step verification or multi-factor authentication on your account. This will make your account more secure, but you will need to enter every time you want to log in to your account. You will need to enter the email address, the password, and then a code from the second step verification. You will be able to choose different methods, but to start setting up the second step verification or two-step verification, you'll need to click on the circle with your initial on the top right of the screen. Then click the blue Google account button. From the left side menu, select Security, and then scroll down to how you sign in to Google options, and then verify if the two-step verification is on or off. In my case, it is off, so I will click this option and I want to turn on two-step verification. Here from the bottom, I can choose what kind of second step I want to receive the code from or to. For instance, I can use passkeys and security keys. I can use a Google prompt on my Android phone. I can use Google Authenticator to generate a code so I can enter on the login screen. And I can add a phone number to receive a short message service with the code. I will choose the Google Authenticator. So I will click the Add Authenticator app option so I can create a token on my Google Authenticator app on my phone so I can receive the code from the Authenticator app and enter as the second step verification for logging in. If you want to add an Authenticator app to your Google account, click this option and click Set up Authenticator. Now you need to scan the code on the screen to link it with your Google account. Upon scanning the link, my phone asks me which application I would like to use to open that link. I choose the Google Authenticator, and now the Google Authenticator is asking me to add a token. If I want to add a token for this account, and I click yes on my phone, and now I have a token for this account on my Google Authenticator app on my phone. So now I can click next here on the screen. And from the Google Authenticator app on the phone, I will type the code here. So this code is generated on my phone by the Google Authenticator app, which I included or linked to this Google account. Enter the code and click verify. Now it says your authenticator was just added. Now I can click the turn on two-step verification button or click the arrow to go back to the previous screen. Here I have the Authenticator app added or linked to this account, and now I can click turn on two-step verification. So every time I try to log into this account, it will ask for the second step verification. It's adding me to enter a phone number. I don't want to enter a phone number for this account because this is a test account. I will just skip this step and then continue without a phone number. Yes, I want to continue anyway. This is not a safe or recommended. You should, especially if you have only one Google account, you should enter your phone number. So if you lost the password or if you have any difficulties logging into that account, you can receive codes or recovery codes on your phone to be able to recover your account. This is a lab account. I will delete this account after I record the lab, so I don't want to add a phone number to this account. So it says you are now protected with two-step verification, and it shows the option I will receive the code or will generate the code so I can enter after I enter the password to perform the login. If you reach this step, click done and setting up multi-factor authentication on your account is finished. Thank you and see you in next lab.
All right. Everybody got their multi-factor authentication set up? I swear my Google Authenticator has like 19 token things on it at this point. Leo or Mike, you wanna add anything, or?
I did not demo. Please go ahead.
As far as things go from right now, everything feels fairly straightforward that we're describing to me. But, just because it feels straightforward to me does not mean something feels straightforward to you. We all have different things. We all have different expertise. We all have different things they know. So all we care is that you've got a great experience, that you maximize this Google Professional Cloud Architect Bootcamp. So if you've got a question, please don't hesitate to ask. We want to do everything that we can. And then, Chris, do we have anything else? One more?
We've got the budget walkthrough, but Leo, you got any commentary?
Well, I just did not demonstrate after creating the second step verification, but every time you log in, you need to enter the username, password, and the second code for the second step verification.
Yes, absolutely. All right. Well, let's get on with creating a budget. The next one's going to be a little bit longer. It's about 20 minutes. So make sure you're comfortable and ready to go.
Yeah.
Hello. In this lab, I will demonstrate how you can create a budget and set an alert when that budget is reached or exceeded. After you go to cloud.google.com and perform your login, you will reach this screen. You can click Console, and then you are taken to the welcome screen of Google Cloud Platform Console. And to create the budget, you can select the option Set up Budget Alerts from here, or you can click the navigation menu and then click Billing. Then from the billing overview window or page, you can select budgets and alerts. You can click Create Budget from this option on from the top here and see that there are documents and tutorials for helping you doing this activity. If you need help, please research Google documentation for that. So enter a name for your budget. I will enter a very suggestive name. This is a lab recording. Please consider this. If you are doing this for an organization, for your work, choose names that are in compliance with the organization's policies and standards. Here under time range, you can select the period you want your budgets to monitor the spending. It can be monthly, quarterly, yearly, or you can set a custom range. I will just leave the monthly option selected. And here the read-on option, it is just for protecting the budget from unwanted deleting or modifications. For this lab, I don't need to set up that option. And for learning, you also don't need to set up that option. Here under project, you can select the specific project you want the budget to cover or to monitor, or you can leave all projects. In this case, I only have one project, but I will leave the default option selected. Here under services, if you don't select anything, if you accept the default option, the budget will monitor all Google services possible. You don't need to choose which services you will want to monitor. But if you want to choose the services, please open this option and select the services you want from 1,792 possible services Google offers. Here under the labels option, you can enter the key and value for the labels let's say you want one budget to monitor the development department. So all services created for the development department or by the development department, you should add a key value pair, a label for those services. So this budget or the budget related to the development department will monitor all the services with that label. And this is valid for how many budgets you want to create. You can create different budgets. And if you want to monitor by labels, every time you create or add a new service to that department or that account, you should add the label to that services so they are monitored by the budgets. I will not add any labels here. And for credits, you can leave the options as they are selected. This will include every credit, promotion, offers, discounts into the budget. This means the budget will also monitor the free tier services you use during the time the budget is monitoring your service. Leave them selected if you want and click next. Then we need to set the amount for the budget. Here you can select a specified amount, a fixed amount, or you can base the current month budget on the previous month. So you can use last month's spend as the budget limit for this month, or you can specify a fixed amount. And if you don't change that every month, the limit for the budget will be this specified amount. Here under target amount, it's showing my local currency here, and it will probably show your currency, which is different from mine. For this lab, I will create a budget for 10 units of money. In my case, it's Brazilian reais. And I will click next. In this next page, I can set the thresholds for the alerts. My total budget is for 10. And if I set a threshold for 100% of this budget, it will trigger a notification, an alert, when total consumption of services on this account under this budget reaches or exceeds 10 reais. I can set different budgets, different percentages. Let's say 90% of the total budget will be 9 and 50% will be 5. And here you can trigger on the actual spend or consumption of the services or the forecasted. The actual will trigger the notification when the actual value of 5 in this case is reached or exceeded. If you set for forecasted, the notification will be triggered when, based on the daily consumption, 5 is forecasted to be reached during the month. So if your total amount is 10 and you want to forecast when 5 will be reached, the notification will be sent when the forecasted value of 5 is reached. I will just leave actual spend here for my triggers, my thresholds, and I will add one more threshold for 1%. So whenever 0.1 units of money are spent on this account, a notification will be triggered. Here you can manage the notifications or the types of notifications you want to receive. The default option is email alerts, but you also have the option to add different accounts, different email accounts. The first option is email alerts to billing admins and users. In this case, the only user of this account will receive this email alert. If you create other users for billing admins or other users on this account, billing users, they will receive the email notification as well. You can link monitoring mail notifications channels, which is selecting a project and maximum of 5 monitoring mail notification channels. And the last option is to connect a pub sub topic to this budget. Using this option to connect to a pub sub topic, you can send notification alerts for Slack, for instance. If you have a department that is responsible for monitoring the consumption on the accounts, they can receive alerts on Slack when the trigger is initiated, when the threshold is reached and the trigger initiated. Not all services update the billing immediately after the service is consumed. It could take some time after the consumption of the service. Let's say you created a virtual machine, you terminated the virtual machine. The consumption could be updated on the billing hours after you terminated the virtual machine. But anyway, choosing to connect a pub sub to use Slack, for instance, for notifications, will take a little bit of coding and using other Google services like Cloud Run to send the notification to Slack. It's a little bit more hands-on option to connect to a pub sub. But for this lab, I will just leave the email alerts as the option for receiving notifications. And once I do that, I will click Finish. And my first budget is created for a monthly period for a total of 10 units of money. You can click the name of the budget to see the details. And you can also add more triggers, more thresholds. You can do modifications and then click Save. For now, the budget is created. Right now, I don't have any consumption. I haven't used any service to trigger the notification by email. But after recording the labs for creating virtual machines and using different services, I will check the budget, how it is, and if the threshold was exceeded, I will receive an email in this account, and I will add that email to the end of this lab. It will be kind of a time travel, because I will go to the future when I actually have some consumption of services on this account, and then I will go back here and add the example email with the notification for the consumption of the services, which I don't have at this moment. After creating that first budget, I did other activities so the services or the consumption of the services could accumulate. But then I noticed that since I included the discounts, promotions, and offers in the budget, it doesn't show the services I am consuming, or at least the budget will only step from zero when the $300 expires or are used. Then and only then the budget will start increasing the values. Because of this, there was no email, no alert email sent by this budget, because it still shows 0 out of 10. For this reason, I will create a second budget here, and this time I will unselect the promotions, discounts, and other codes that do not allow the budget to show the consumption of the services I am having while using this promotional period. I will click Create Budget. And then I will name it my second budget. I will try a custom range from January this year up to July 1st. I will allow all projects, since I'm creating projects and removing projects from this account. I want the budget to monitor all projects. And I will leave all services selected as well, so the budget monitors any service I use. Here I will unselect the discounts and the promotions and others. Now I'll click Next to go to the amount section, and I will keep a specified amount, and this time I will enter, let's say 200 Brazilian reais. And there are some triggers here for sending the email alerts. I will accept them. There is one for 50% of that total, which represents 100, then 90% of the total, and then 100% out of the 200 Brazilian reais I set my budget to monitor. I will accept the email alerts to billing admins and users as the form of alert to be sent, and then I will click Finish to finish creating this budget. Now we can see this budget already has some services monitored since I set the period from January 1st to July 1st. The services I have already used in the previous days of creating this budget, and we can see there is already consumption of services that is reported by this budget. Since I set the dates from January 1st to July 1st this year, all the services I have consumed during the previous days of creating this budget, those services are already reported here in the budget. Whenever the budget reaches the triggers, 50%, 90%, and 100%, the email alerts will be sent, informing about the threshold being reached. As I mentioned when creating the first report, I will wait for the thresholds to be reached and for the email alerts to be sent, and I will come back with an example of those email alerts. I will click Cancel because I didn't do any modifications on this second budget, as I did for after creating the first budget. I will wait to consume more services from the Google Cloud Platform, so the thresholds are reached, and then the alert emails are sent. Some days and some lab recordings later, the services accumulated expenses on my Google account. At this point, I have received the email alerts for 1% budget, 50%, 90%, and 100%. And one of these emails is like this. They bring the percentage reached and they inform the budget amount. And that's it. The others, the 90% budget, the 50% budget, and the 10%, the 1% budget. To delete a budget, You click the name of the budget, and then you click the delete button. You click delete to confirm you want to delete the budget. And then the budget is deleted. In this lab, I demonstrated how to create a budget and how to set thresholds to trigger sending alerts. I also mentioned the different ways you can use to send alerts when the thresholds are reached. Thank you for watching and see you in the next lab.
All right, everyone, we are back. So I think there was one question that I'm going to go over that I may or may not have misinterpreted the question in the chat box. What is a host name? And then if there's any other questions for Chris and Leo.
Oh, no, not for me. I'm just here to moderate the two of you. So
if you have a coordination question or a facilitation question, send that to Chris. If you've got a lab question, send it to Alonzo. If you've got an architecture question, send it to me or a business executive.
We are not sending anything to Alonzo. So I'm going to leave it with you, and I'm going to leave it with you and Leo. I will remain in the chat box. Have fun with any questions that you have. Let me put up the first one.
Hi all, what's the host name? So let me talk about what is a host name. So Chris, I want to go to full screen right now. And what I'm going to do is I'm going to actually share something. I drew it when that question was coming in. So if we actually look at, I'm not exactly sure what's going on there. So let's go back to, if we go to a fully qualified domain name here, it's going to have three components. And the three components of a fully qualified domain name are going to be the host name, which is what you call it, the domain name, which is the domain that the organization owns, and then the top level domain. So if I call my computer Cindy, and I have a computer named Cindy in my house because my cat does like have a computer that she likes to walk on the keyboard, and I don't want it to be mine. So Cindy can't really do any damage on her computer. She's got her own. So that machine is named Cindy. It's not plugged into anything. There's no real internet access, but the keyboard is there. So if she walks into it, it's no big deal. Now that would be the host name. So the host name is just what we call it. The domain name, again, is what we register. And the top level domain could be .co, .edu, .net, or what have you. So it's just what we call it. The system is its host name. And typically that'll fit into a DNS server or an Active Directory server. So you'll be able to use a name to connect to it, not its IP address. Great question there. We can both come back now, Chris.
Apparently Alonzo is in the chat box. So if you have questions for Alonzo too,
you could ask him too.
Yes. So
I recommend marketing questions for Alonzo, or of course you could do any architecture, AI, or otherwise.
But yeah, so I'm going to let Mike and Leo stick around for a few more minutes if you guys have any questions. Now, keep in mind, this is just the beginning. We've got IAM tomorrow. We've got networking Wednesday and Thursday. We've got compute and containers on Friday. And then next week, we're going to be covering security and databases and storage and all that fun stuff. So we're going to be diving a lot deeper into all of this. But Samuel's got a question.
So Samuel's question is, what is a fully qualified domain name? So a fully qualified domain name is something that has a host name, a domain name, and then that top level domain. So let's talk about the difference. And I know you, Samuel. So let's imagine we just wanted to reach a name, a host inside of our entity. And I could make it Leo's Mac, Chris's Threadripper workstation, Alonzo's Mac, Mike's whatever home-built crazy system that he's got running over here. I could name it anything I wanted. And inside of my domain, I could actually have a host file that's out on everybody's computer that says Cindy, and all you'd have to type is Cindy and it would reach it. Now, I might instead use Active Directory or some kind of directory service where I could just enter a name inside of my domain and I could literally reach a system. Ping Leo's computer. And it would work if we had a host file or something internal to resolve it. Now, if we're in an external environment by comparison in the internet, how do we send that traffic to where it needs to go? How do we resolve that traffic when it's off network? And that's where the DNS servers really are coming in, where I send it a full name. So it's leosmac.gocloudcareers, which is our domain, .com. And that way I could just ping Leo's Mac or SSH to Leo's Mac if I had access to it, as opposed to remembering Leo's IP address and connecting to it via its IP address. But that's really all it is. It's just adding the host name plus the domain name plus a top-level domain. And that's why you can go to training.gocloudcareers.com. The training or subdomain is actually effectively functioning as a host name. The Go Cloud Careers is our main domain, and our top level domain is .com. So that's realistically speaking what we're talking about. I hope I answered your question there, Samuel. So it looks to me like questions have dried up. I think Leo and I have kept you guys busy now for 4 hours. 4 hours on the Google Professional Cloud Architect. It's just the first day, and we got 2 more weeks. So if you want to catch up on anything, go look it up. Go rewatch something. If you've got an area of question, we're going to leave this up. If you've got a friend that you think would benefit, please invite them. Maybe like it, share it, do what you can, and send this to others, because we really want to help as many people as possible. Leo, have any last words today?
Well, that this is very educational and very entertaining. And if you all like the content and the labs, share with your friends, with your colleagues, and come back tomorrow.
Come back tomorrow. Leo's modest. He's got over 20 years of expertise. So come back tomorrow. We have